So this is a test. This is fine. Test, 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 1, 2. Test, test.
Morning. In training room 3 had je wat clipping. Dat was overdingest. Nee, dat was training room 1 die weg is. Ah, juist. Ja, sorry. Enfin, in ieder geval, er was wat clipping. Wat hè? In de room waar dat we zien binnen, die hier nog als training room 3 gelabeld staat.
Test.
Ja, en in de andere training room is er bus. Dus ik weet niet of we daar een DI-box steken hebben of niet. Hebben we daar een? Ik zal er een gaan halen.
morning ใส่กูก็morning ใส่กูก่อนเลยกูอยากจะถือทับเลิกเงินเลิกเกินอยากให้มันเป็นวันเย็นที่ดี
Test, test, test.
One, two, one, two, one, two. Hello, hello, hello. Good morning. Hello. Good morning. Fantastic. Welcome. I'm Roland.
Yeah.
So the question of the moment is slides.
Oh, yeah, yeah. Slide. we have an online slide. Online.
Okay.
That should be just open the link.
All right.
So, we should use this computer? Or,
It's
This computer, yes.
and I...
the recommendation is that you do if you can.
And please open the browser, and my slides is on the website. Thank you.
The microphones, everything should be fine.
Yep.
Come, you should use.
1 2 1. Quiet. 1 2 1 2.
Okay, so I have no sound in the other room. After I'm finished, I'm going to tell them.
All right. Thank you.
Yeah, we asked people already. Sorry, they're coming. Guys, bit like.
Yeah,
You'll be moderating here all day. You'll be moderating here all day. This room.
I assume it's all the same day, same room. I haven't actually checked that.
Let me check for you. No, because like in
It
the
seems
afternoon
logical.
there would be some gaps. There one speaker yesterday asked me if we could come for lightning talk 5 minutes.
Right.
Yeah, so there's a gap like 20 minutes from 3:20 to 3:45, like a big gap. So if you just like squeeze in and have a short talk.
I have no great objection. I know we have a general rules. We run to what's on the schedule.
Yeah, so I just want to let you know, just in case. I need to check the moderator.
哎，行，你知道它的那个公开那个
That's are they already in schedule?
Oh, you mean the guy? The speaker? No, he wasn't.
Meaning their talk hasn't been evaluated.
But is it lightning talk? I was not sure. I don't know. But you're here, so I see you. Because like last time when Mario, like when I was doing the lightning talk, Mario just asked me, okay, you come here. Okay. So, okay, but yeah, I'll
It's generally fine. We haven't actually had our half.
yeah, but yeah, I'll also check the next time.
But yes, if you ask them to come and find me lunchtime, they won't find me.
Do you need coffee? Just let me know. Yeah, no.
It's a tough time.
You're presenting first.
I'm moderating. He's presenting. Good morning.
Morning.
You are Ian and Richard. Is that correct?
Yeah, Ian and Richard. Yeah.
Right. Richard and Ian.
Okay, I get that.
Is there a chance I can check my presentation and present at 9:30? Just want to make sure that it's...
A bit late now.
There was nobody here for the last half an hour. I've been in this room, nobody was here.
So the way it works, we've got 5 minutes between talks usually, and that's the case here. This is you?
Yes.
Yeah. So the way I will coordinate it is, if there's Q&A, although I don't like their odds, what I normally do is at the end of their scheduled slot, which is 9:25, I will intervene. I'll ask you to come up and set up. And at that point, you don't need to wait.
Okay.
They can be doing Q&A in the gap until you're ready.
Okay,
But
okay, okay.
sometimes you get people going, okay, I'll now wait for them to finish. So, no, it's the other way around.
Okay.
I am running them through Q&A while I wait for you to be ready.
Okay.
So yeah, at 25 past, I'll invite you up, and maybe they'll have finished, maybe they'll be doing Q&A, but either way, my aim will be to have you start on the 9:30 start.
Okay. I'm presenting from the laptop that is here.
We
yes.
recommend it. If you
I have a Google slide, so they should be
That's fine.
somewhere
It's just a web browser.
ready in the.
The web browser. So, oh,
And
yeah, there's a
when do I
drive
take a
folder.
link? It should be somewhere in the.
hopefully.
Yeah. So how does it work?
I actually don't know the answer to that question.
How do I start?
We've got a few minutes, let's have a look.
Yeah, this one is mine.
That is you.
It's downloaded as PowerPoint. It's bad. Can you try to click this link? Oh, it's bad.
Stand by.
No, we can download and probably
There
click
are
it.
many ways to get the skin off the cat.
I have linked original slides on the slides, so it should be fine.
I'm wondering, we're having strange problems getting presenter mode to work correctly, even for Google. Just odd.
It's fine. But the embedded videos, I guess they will not be open. Can you just click this link? I think it will be more
I've got a
better presentation.
Downloaded. Oh, that's not you. No, that's us. Beg your pardon.
Transition.
All right.
Click this
Let's
link.
try that one. I
yeah,
reckon
the
that's
span
the
should
same
be
place.
But this one should be correct. No, this one is fine. I think it's a bit different one. Yeah, can you click one more to one more slide? There is like video. Just wanna check that.
Oh, I see. Okay, yeah. Okay.
So this is why I use the.
Sound might be a bit exciting.
Yes.
You don't need sound. You just need to show them. together.
No sound.
Okay.
I don't need sound. Yeah. Okay, it seems it works. So yeah, can you just keep it?
Yes, of course. Yeah. I would. This is. Thank you.
This
'Cause
one I can close.
I would-
I
I'm-
guess. But
leave it all alone at this point.
okay.
Where down? There he is. Okay.
Thank you.
But have a seat, and I'll let you know when. It's the browser. Okay. Sorry, did I knock you out of full screen?
Yes.
Do you want to put that back? That's okay.
It's okay. It's
Okay.
okay.
No, that's, all right.
And I heard of your talk yesterday. I feel insightful.
Thank you. I'm like everyone. I came out terribly because seriously, I was chopping material out 20 minutes before the talk.
Oh, really?
It wasn't going to fit.
The same me. This morning, I just done my
You've
slides.
got- right, so it's the same problem. That I'm like, this is a 2-hour talk and it's not going to work. And so chop.
I think it's iteration because I check your website and I see so many talks before you
Yes,
talk.
yes.
So yeah, I know you are studying this topic for many years. Yeah.
That's many.
So you are a lawyer?
Many
or-
years. No, actually, that's the one thing I'm not.
Oh, you're not.
I am-
Because I maybe let me think you are a lawyer.
I've been involved in contract negotiation since my 20s and mediation, but only always instructing a lawyer, not myself a lawyer.
Okay, I see.
But I've been involved in advocacy for open source licensing since 98,
Oh, 98.
when Mozilla first opened up the discussion about its license.
Very early for me.
It was me who proposed the dual license structure that the Mozilla Foundation still uses.
Wow.
Because they were like, no, we have to be able to sell this to our corporate customers, but the free software guys. So well, why don't you just make a choice? Allow the licensee to take under either license. And they finally, it took a while, but they finally said,
Yeah, good.
and they still do.
Because MPL is not so popular, so
Yeah, and so that was the point. They do,
Yeah.
for MPL, either 1 or 2, they've built in options to say you can, at your option, switch to LGB or UPL.
yeah.
And they to the MPL code stream, which in theory can be licensed. Or you can detail software not applicable. That was an argument. It took 2.5 years to get implemented after the code stream. But,
Great.
so, yes.
Very nice to know you.
Been at this for a while.
Yeah.
All right.
9 o'clock.
It's 9 o'clock. I wonder if it's deliberately start late.
I would suggest so.
I prefer to write on the schedule, but it is 9 o'clock on a Saturday morning. I think we're a little bit.
Roland, would you mind taking the stage for a moment? Because it seems like someone got into the show.
Yep, I understand. Okay. Good morning, all, and thank you for being here on time on a Saturday morning. Although I'm usually the sort of intolerant, we are running to schedule guy, I think this morning I might let it slip a few minutes because I think we're all feeling a bit ragged after those who went drinking last night. So I do appreciate you being on time, but please give us a few minutes. Thanks.
Test. Now it's perfect. Okay, this one is okay. That's it. Thank you. All right, that's about as much sloth as I'm willing. Good morning. Welcome to day 3 of the FOSSASIA Summit. Who was out drinking last night? Apart from me? No? See, that's why you guys are here on time. Well, congratulations. My name is Roland Turner. I'm part of the FOSSASIA organising team, have been for about 10 years. Been working, using and developing and advocating software freedom since the mid-90s. So it's a sort of hobby that's bleeding into my work in security, which is nice. This morning we are starting with Ian Zhu and Richard Lin from OpenBuild and I'm not going to pronounce that, respectively, who are going to talk to us about building a Web3 developer ecosystem. Guys, take it away. You can have this.
Okay, thank you. Okay, thank you, everyone. My name is Richard, and this is Ian. And at this talk, we do together. But because my English is a little bit better than Ian, but worse than you, so maybe you should tolerate us. And now I will. I'm very happy you come here because maybe Web3 is. Sometimes some people say it's popular, but some open source guys say maybe it's not a cool technology and maybe it's used to fraud and something. So it's very maybe not a good topic. And DevRel, a developer ecosystem and a developer relationship, maybe I'm not sure if you are interested in. So if you take a photo of me, you can send me later. Yeah. So yeah. Okay. I'm Richard Lin, and I'm co-founder of 开源社. 开源社 is a Chinese open source alliance. I'm the co-founder, and previously I'm the volunteer and organizer of Coast Cup. Coast Cup is we have a booth. Yeah, and the Coast Cup is a Taiwanese open source conference because I'm come from Taiwan and I moved to China for 12 years. I previously was open source lead in Huawei technology. Maybe you heard of Huawei, right? And I left Huawei and into going to a big AI model company called 01.ai. It's founded by Dr. Kai-Fu Lee, and I was there to responsible for open source and the developer ecosystem. So AI, open source, and DevRel is my focus. And now I'm studying Web3. Yeah. So Ian. Ian is a founder of OpenBuild. OpenBuild is a community who bring Web2 developer and so-called traditional developer join to Web3, and he will offer many courses and many paths for Web2 developer join Web3 world. So he also a co-organizer of Rust, CC, and PyChina. Yeah, it's a very it's a very big conference in China. Rust CC is a community, and PyChina is the head of PyCon, and he also the board member of 开源社. Yeah, so yeah, we work together. And overview, I want to talk about DevRel. And have you ever heard of DevRel before? Yeah, raise your hand. Oh, okay, 5 people, but I'm I'm happy, and I want to talk differences between in DevRel between Web 2 and Web 3 and the global in China. Then I want to state some statistics and the challenge of Web3 developer ecosystem. Then Ian will introduce the pathway for developers to join the Web3 ecosystem. Then if you from Web3 project, you want to build your ecosystem, what is your strategy? We will introduce our experience. Then long-term reason of Web3 ecosystem is very, very important. The latest, I will share of action. And what is DevRel? Maybe if you don't heard of this before, you should read this book. This book is called Developer Relations: How to Build and Grow a Successful Developer Program. And if you can read Chinese, I'm the translator of this book. I translate this book into Chinese. Yeah, because I think when I go to China, I think no one knows DevRel, developer relationship, because many people know public relationship, government relationship, investor relationship, but don't know developer relationship. So if you can read simplified Chinese, you can read this book. Is my work. And this is from a Canadian author. And this book is, I read it's very good introduction. So, yes. And what is DevRel? You can see this. In the core is it's like a tree. You can see, and in the core is developer experience. Experience is the most important thing in DevRel, because if you have a good experience, then developer will join you, and you can build a community for your foundation, your fundamental. And there are 3 things: developer marketing and developer education and training, and then make developer success. Make the developer success is the goal of your ecosystem. So if you can do something, do an architecture and do a community and do some evangelist, you will make your community and the developer success. So it's a DevRel's core. Okay. So let me introduce maybe Web3. I'm not sure if you heard of Web3. If you heard, you can raise your hand. Web3. Okay, it's more. Okay, so it's popular than DevRel, I know. And Web 2 is maybe the term is not so popular, but we say most of the developer are Web 2 developer. We can see the portrait. For example, the profile. We can find many experienced developers in the Web 2 developer field because we are all learn coding and learn computer science from this area. But Web3 is very new, so we face some problem that there are many new graduates, no prior developer experience. The people, maybe they just know Web3 when they are a student. So they have no industrial experience. And they just join Web3 and do some so-called Web3 projects, maybe in protocol in layer 1, layer 2, or some smart contract. It's very easy, but sometimes not secure, sometimes not good enough, not met industrial standard. So maybe in this time I see this. And strengths. You can see Web2 developer, we can find many people who have solid developer experience. And Web3 developer, because they are open-minded. Some Web2 developer join Web3. Some Web2 developer join Web3 because they are open-minded and more respective to Web3 concept. But Web3 concept is maybe not acceptable. Not so popular in our developers. And the challenge, maybe some people skeptical about Web3 cautious attitude. They say, what is that? Should I join into and concerned about career risks? Because many Web3 career is like a project and the remote work, and even they don't have the legal entity in your country, right? So yeah, it's a little bit career risk, and maybe you don't have a social insurance. Yeah, so it's a challenge. And Web3 developer lack of technical skills, maybe too junior, and job stability is Web2 is more stable than Web3. And sometimes Web3 developer face higher volatility because the market value, for example, the Bitcoin or Ethereum, and go up and down, up and down. So some people their salary is the grants, so it's a challenge. Okay. Not so stable. And then I will share about difference between Web 2 and Web 3 developers. The DevRel. And if you are a company or the booth there, I think, for example, TiDB, I'm familiar with the TiDB because the founder is Chinese people. I know him. That's a very good open source project, but the community is like a little bit centralized than Web3. Because corporate driven this community to build their commercial success. So they want to control and want to collaborate with the community. And the Web3 sometimes decentralized and very open source, like, for example, Bitcoin. There are many players in Bitcoin ecosystem, and they just follow their white paper and follow the architecture. Maybe no one, many people, even they compete in the ecosystem. For example, DAO, decentralized autonomy organization driven community. It's very new idea for me. Yeah, so maybe we can learn and try some method from Web3, or you just join the Web3 community to feel that. And developer engagement, for example, traditional, we will have some traditional marketing, workshop, conferences, and training course or something. And the Web3 DevRel, they keen to do more hackathons and some bounties, because I have some question you will solve and I give you the grants. The grants maybe you can you can transfer it to US dollar in the exchange, right? So token incentive is a very good part is a very good advantage from Web 2. And monetization, salaries, cooperation, partnership is a traditional way. For example, of Austin, we want to get some sponsorship from the from the companies. So it's a traditional way. And maybe if we can do debt-free projects, grants, airdrops, ecosystem funding, it's a new way. Yeah, so I see, for example, Gitcoin, maybe you heard of it. They try to do some airdrop or something to help open source project. And governance, yeah, Web2 is corporate-led decision. And Web3 is developers, they just want to have a say. Via DAOs and token governance, they can join if the project they want to then join, then it's very easy. And so key challenge is that adoption of new tool for DevRails is hard, and the developer retention. Okay, and the key challenges for Web3 DevRail is security risk, trust in decentralization, because the trust is the most hard thing to us, and fragmentation of developer resources and a high market volatility. Okay, and global in China, I think because I'm living in China for 12 years, and before that, I see more a global community, so I can compare with that. Global DevRail, maybe the culture in global is open discussion, direct feedback, but in China, sometimes relationship is more than, for example, I know someone in the company, I know someone in the project, and maybe we won't do work in public way. Maybe we will, because I know him. So in direct communication or not transparent to the community. Yeah, it's a different culture. And a platform, maybe in global is Discord, Twitter, GitHub or something, for example, Matrix, okay. Yeah, it's a open source way. And China DevRail maybe use WeChat, okay, WeChat group, or 知识星球 is another Chinese, and Git. Git is a clone of GitHub. It's a biggest Git platform in China. It's called Git, okay. So, incentive, maybe token incentive widely accepted in the global, but in China, mixed incentive model, emphasis on the practicality. Yeah, so yeah, and the content strategy, global is a technical depth. Open source contribution, they focus on this. But China developer, they care about practical use cases. How can I use these cases to earn money immediately? Yeah, so it's Chinese people think, and the business value is important. Then the last thing, policy and compliance. I think global DevRail for Web3 is open, but in China, many global people think China, they banned Web3, but actually I think it's, just 10 minutes, sorry. It's not. For example, token trading is very restricted in China, but technical collaboration, project contribution, and the community organization are fine. They are fine. So we build many Web3 open source community in China, and we don't ban it from the government or society. Yeah, and we can share some statics. This you can see this report is by Electric Capital. You can find it online. It's developer report, and you can remember Electric Capital. This report is very, very rich, and I can share some. For example, in the Web3, developer grew 39% per year from 2015. Yeah, you can see. And recently, down a little bit. But the trend is up. Yeah, and approximately, you can see just 23,000, just 23,000 Web3 developers all over the world. So it's very little for me. The amount is very little. And I'm shocked when I see this report. Yeah. So maybe the market will go up later. And you can see when 10 years ago, there are 43 North American Web3 developer. Then 2020, last year, Asian become the first. Yeah, we have 32% in Asia. Yeah, so we can see Asia Web3 industry and the developer is up. Yeah, and you can see there are over 1/3 of developers. They contribute to multiple public chains. Yeah, that means many public chain they need a developer, and the developer have many choice, and there are not enough. Yeah, a developer supply shortfall in Web3 industry. So there are many opportunities here, and sorry, I forgot to translate it. Yeah, our observation. Yeah, developer demand. We lack of 5 to 10 years experience. The senior developer very lack of 5 to 10 years experience, and the salary level we observe that in Web3 is higher than Web2. Yeah, maybe 30 to 15. And higher difficulty. This is to the public chain or to the project. They are very hard to hire people, and the entry barriers. Some for the both sides. So developer maybe feel some entry barriers, and don't know how to join. And maybe Ian, you can share some pathway for developer to join because he directed face the.
Hello guys, nice to meet you. Yeah, I'm appreciating to discussing the pathway for developers to join the Web3 ecosystem. And I'm the co-founder of the OpenBuild, one of the Web3 community. I met many different developers from the Web2, and they want to join the Web3, but how to do so? Conclusions, 4 steps is very important, but as we have a little time, say it simply. The first is mindset your shift. It's very important because you can't understand Web3 just through the technical ego, because it has a built-in financial. Yeah. And second is the best way to join this is join community and contribute to open source, because all of the Web3 projects is naturally open source. Yeah. It must be open source. And third is improve communication and cooperation skills, because most of the Web3 company are global company and work remote. Yeah. And last, be patient about the new technical. It's AI now. The Web3 also every day have the new new tools, new thoughts about this industry. So keep patient is very important. And this is a story or a case from our community. You can see this one. It's called Ego, and you can see its GitHub is crazy. It's submit PR every day. Yeah, yeah. You can take a photo. Yeah. Also, he is a traditional developer from the bigger company, and and he wants to join the Web3 about from 2023. And at first, he just next most of people, he to watch videos and tutorials, but it's very slow. And then we told him you should to do a open source project, and he also have a open source project. So we connected his projects to Web3, and through this way, he learns the technical in Web3 quickly. And also, we help him to find the new contributor from the Web3. And last, we also help him to get the grants and bounty from the many different Web3 foundations. Now, it's totally about 15,000 donors from his open source projects. It's keep his the confidence to build the Web3 the open source projects. Yeah, and we can to have 4 key message or insights from this. Yeah, but it's a little time I don't read it. So let's come back, Richard back. Yeah, to tell you about how the company to build the Web3 ecosystem.
Yeah, actually, I just have 5 minutes, so maybe I can, or 3 minutes, okay. And yeah, so these slides I can share with you in the last page. So I just skip because maybe it's too long. And I just want to say the importance of a long-termism is very, very important. I think Web2 developers and the open source project developers, they know this. But the Web3 developers and the project, they are in a hurry. So yeah, so maybe the value I don't dig in, but long term is very important. And the double-edged sword. Yeah, double-edged sword is of token. Token is good, but token sometimes hurt. So some positive you can be the incentive, and some negative impact short-term speculation, quality degradation, and some not good airdrop. Yeah, so you should focus on the relationship between the developer and your project, how to be friends and how to engage and how to let them be loyal to this project. And you are not a king, you are the friends, and we join to fulfill our common goal. Yeah, it's a very important thing. And maybe we just can skip this because it is very, very complex. And the call to action. We are for developers. We mindset should shift, and maybe we can join the community of Web3 and contribute to some Web3 open source project, improve communication and collaboration, and keep learning. Yeah, I'm learning too. Yeah, and for a company maybe to think about DevRel. Why you should do DevRel? What is your key point? Yeah, so believe in the long term. And Web3 represents a revolution in open source collaboration models and values. That's my quote. Building an ecosystem is marathon. Be patient. Yeah, so I think community over code. I learned from Apache. Yeah, so you should know this. And thank you. So this slides. This QR code is these slides, so you can take a picture and scan this. And I'm Richard Lin. I'm from Kaiyuan She. Yeah, and Ian Xu is from Open Build. So maybe you can contact us, follow us Twitter or email us and add me on LinkedIn. So today is the last day, but on the internet we can communicate every day. Yeah, so yeah, so keep in touch. Thank you, thank you.
Thank you very much. Some of the work I do in Singapore is on exactly that sort of institutional security stuff and developing. Apparently, we're the first group in the world to be developing a standard set of security controls for blockchain and DLT applications. So yeah, it's not just that the developers are inexperienced. Yeah. It's that all of the usual sort of standards bodies and institutional stuff is also immature. So this is fascinating. Thank you. Before I ask for Q&A, do you want to get your slides on screen, please? Any questions for our speaker? We have room for about 1. No questions? This was aha.
Okay, please.
Yeah, thank you for talking. Very interesting stuff. I am very firmly in the Web 2 world, kind of the corporate, traditional side. I'm very interested in the Web 3 stuff. What would be some like top, the best Web 3 apps to kind of look to right now that are kind of like the flagship examples of the ecosystem and utility?
Yeah, as I just talked about, the Web 3 is most important is his financial feature. So actually, most of the application is useful for this industry is about how to say the international transfer. Like now the Visa and many big companies are support the Web 3 to take the token to transfer. Yeah. So and also we have some interesting apps we should call it DApp, decentralized applications. And if you are just a traditional Web2 developers, you can't understand his logic. But if you know more about the Web3, you will think it's very interesting. So if you are interested, we can talk later. Yeah.
And the financial scenario application is the Web3 the best practice financial. Yeah. Thank you.
Brilliant. Thank you, guys. All right. Bit of a change of gears here. Ilya Lachenko, is that correct? Yes, from Agoda is going to talk to us about the LeRobot library for bridging AI and robotics. What could possibly go wrong?
Yeah, thank you. Good morning, everybody. I'm Ilya. I'm really glad to be here. And today I will talk about the robotics and AI and how can you experiment with the kind of intersection of these two fields using some open source tools, even at home, basically. So before I begin, a couple of words about myself. So again, my name is Ilya. I'm currently a data science director in Agoda, and I live here in Bangkok, in Thailand. I have a bit more than 12 years of experience in machine learning, data science, analytics, and connected areas. I used to be pretty active on machine learning competitions in the past. But today, the topic that I'm going to talk is not kind of directly related to my work, but related to my hobby. So I've been doing robotics as a hobby for quite a few years already, in and out. And this presentation will be more like from the hobbyist perspective rather than from the professional from the robotics field. And before I begin, just wanna understand the audience a little bit better. So please raise your hand if you ever try to do anything related to robotics. So okay, nice, quite a few people. And now the same question about machine learning and AI. So who ever trained any machine learning model themselves? Okay, great. So we have quite a few people who did it. So let me begin. And first of all, just want to give you a very quick overview about the overall approach to robotics. So I would say generally, historically, whenever you wanted to teach your robot to do some autonomous things, you use this what's called classic approach, when the algorithm of the robot has three main steps. It's perception, planning, and control. So perception step is when you take some raw sensor data. It can be, I don't know, some either some sensors, so let's say pictures from the camera, and then process it into something more interpretable. So let's say if you're controlling some robot arm, you want to grab some object, so you take the picture and recognize what are the coordinates of this object on this picture. The next step is usually planning, when you take this data and kind of create the high-level plan for the robot. So let's say, okay, if this object is on the right, then obviously robot should move to the right. And finally, the control step is when you take this plan and transform it into the actual actions for the robot. And in robotics, actions usually means positions or velocity of all the motors in the robot in most of the cases. Again, it's very, very high level, but many applications, many approaches to robotics, they work like this. They have these three steps or something similar to this. But recently there is a rise of end-to-end robotics, when it's a little bit different paradigm, where you combine this perception, planning, and control steps into one policy, one model that is usually AI or machine learning model that simply takes raw observations from the environment and directly predict actions. So instead of having some separated steps, let's say it takes pictures from the cameras and predict directly motor positions of the robot. And it's very interesting area that is rising right now. So if you search for in YouTube for some robotics demo, you will see in the last few years there were a lot of breakthroughs in this area and a lot of very, very cool things that robot learn to do using this approach. And today I want to introduce you LeRobot library. It's like a library that allows you to do the whole cycle of experimentation in this end-to-end robotics. So this library is developed by Hugging Face. It's a well-known company in the area of open source machine learning, probably one of the biggest players in the market. And LeRobot is basically the robotic initiative. And currently this library allows to do like the whole cycle of robotic experiments. It allows you to control robot through teleoperation, collect data set, train state-of-the-art models to control a robot, deal with simulated environments and so on. And in this presentation, I will basically go step by step through all of these things that I mentioned. So let's say you want to do robotics, and probably the first thing you need is robot. So let me introduce this robot to you. It's called Standard Open Arm 100 robot. And it's developed by the Robot Studio. And it's completely open sourced robotic arm. It has 5 degrees of freedom. Most of the parts are 3D printed. So the only thing that you need to buy is like 6 motors and 1 motor controller. And the main kind of advantage of this robot is that it's very cheap. So it costs around $130 per arm with everything included. And it's way, way cheaper than usual robotic manipulators. So for example, some manipulators that usually used in research, they can cost like few $1,000s. Some industrial ones that like heavy things, they can cost like tens of thousands of dollars. But this one is like very small, cheap, and affordable. Of course, it's not as strong. Of course, it's not as precise, but it's more than enough to run AI experiments, simple AI experiments at home using robotics. And yeah, I will talk about it on the next slides. So as I said, most of it is 3D printed. So basically, you need maybe like 20 hours to print all the parts of this robot, depending on your printer, of course. And then maybe around 1 hour to actually assemble this robot. You can see some video of me doing it. It's actually a pretty fun process. But if you kind of don't like it, or like you're not good at it, even so it's actually pretty easy when you follow the instruction. But again, if you don't want to, you can always skip this process, because there are already companies that sell pre-assembled or at least printed robots. So there are, again, easy way to pay a little bit more and get it's already assembled, but I don't know, from my perspective, it's pretty fun to assemble it yourself. And the next thing that you can do is actually modify your robot. So on this picture, you can see what modifications I did. So this robot that I brought today is kind of vanilla version. But when I run my experiments at home, I use a little bit modified one. So I added a couple of cameras to it. One camera is like a wide lens camera on the wrist of the robot. It's a view on the grasped object. One camera is on the bottom, that is forward-looking camera. And I also replaced the gripper. I think this one that I'm using like a bit more convenient than the one in the original robot. But the main point is that, yeah, you can make a lot of modifications yourself, and community is also doing a lot of modifications. So if you join like Discord group or just search for what people are doing with these robots, you can find they do a lot of extra 3D printed parts. There are many different grippers already available. There are many different modifications of robots when people add one extra degree of freedom, one extra wrist to the robot to make it more convenient. So yeah, there are always some modifications that are being released. And of course, you can use them. You can use your own modifications. And I think it's one of the like fun parts of robotics. So like on top of some flexibility in software, you have some flexibility in hardware, and there are like more degrees of freedom that you can experiment with. So the next thing, after you assembled your robot, you somehow want to control it. Before it learns to do stuff autonomously, you should be able to control it manually. And by default, the way to control this robot is to use another robot. So I have another second robot here. And if you look at it, it's almost the same as the first one. So they're almost identical. The color choice is just depending on what you used for printing, so it's not the difference. But the only difference between them is this robot, instead of gripper, has this convenient handle with trigger. And the idea is you can use one robot to control another. So basically, all the 6 motors that you have in the robot have encoders. It means that at any point in time, you can say what is the current position of the robot, current position of each motor. And this teleoperation that you can see on the video is extremely simple. So you move one robot, you read the positions of all motors, and you send these positions as actions, so it's like targets for the another robot, and just move all the motors of the second robot to the same positions. So eventually you can see that on the video, red robot can mimic all the movements of the yellow robot. It's actually pretty convenient. It's very easy to learn when you do it like a few times, then you know how to control it. You can do it pretty precisely. So it's a very convenient way to control your robot. The main problem of this approach is that you need a second robot. So basically, you need to spend 2 times more money to control your robot, and it's not nice. So this is why, again, community, including myself, developing other alternative approaches to control it. For example, these are my experiments with integrating PlayStation 4 controller into this robot. And so yeah, basically you can control your robot with this controller. There are a few different modes. So on the left, you can see that I just use joysticks and arrow sticks to move the robot a little bit in different directions. On the middle one, you can see that when I press the button, like right now, it moves to some preset locations. And also you can see that sometimes it's like blinking with red, and you cannot see, but it's also vibrating whenever you reach the limits. So when the robot cannot go down more, or like cannot open the gripper more than you're trying to open, it has some feedback. And finally, on the right, you can see that you can also control the robot with accelerometer of your PlayStation controller. So basically rotate your controller, and the kind of gripper will rotate the same way. So these are like my experiments. This is what I did at home. There are many others. So again, in community, I think I've seen maybe all possible game controllers, game pads were used to control this robot. I've seen people implemented some convenient control with touchpad and keyboard. I even seen people doing like control using your gestures. So when you just hold your hand in front of the camera, move your fingers, and robot like follows the same movements. So there are pros and cons of all of them. But yeah, the idea is that you can always save a little bit by controlling it in an alternative way. To be honest, I still think that controlling it with this leader follower arm approach is probably the most precise and convenient. But again, there are alternative ways, and yeah, people keep exploring them. So when you assembled everything, when you have like the way to control your robot, you need to set up your environment for experiments. And again, as I said, I'm not working in robotics lab. I'm just doing experiments at home. So this is my dining table in like my condo here in Bangkok. So I set up the experimentation environment there. So on the left, you can see the follower arm, the red one. On the right, you can see the leader arm that is used to control. It's very important to keep the leader arm outside of view of all the cameras. Otherwise, it will learn to just repeat your actions of leader arm instead of doing some reasonable stuff. And then you can also see I added one more camera. I have like top view camera that provides some strategic view on the whole area where you do your like actions, your experiments. And finally, I have like laptop and 1,000 wires that connect in all these things. And yeah, this is where I run my experiments. This is where I do some tests with my robot. Yeah, so when you have everything set up, the next step is to collect data set. And when I talk about data set in robotics, and again, for this particular behavior cloning example, each episode in your data set is just recording of you teleoperating the robot to complete the target task. So in this example, the target task is to like grab the ball and put it inside the cap. It's pretty simple. And I'm teleoperating robot right now, so it's not in the camera, but I'm somewhere nearby with this leader robot, with this leader arm, controlling this one to put this ball inside the cap. And each episode is just recording from all the cameras, so you can see like 3 camera views. And also you can see 2 charts on top. So they look pretty similar, so each chart has 6 lines on it. And basically, chart on the left is action chart. And it represents the positions of all 6 motors of this leader arm at any point of time. And the chart on the right is state chart, so it represents positions of 6 motors of this like follower arm at any point in time. And as I said, the kind of position of the first robot is the targets for positions for the second one, so these charts are pretty much aligned, but you can see that there are always some differences. They're not like exactly the same, because there is some delay, there is some inaccuracy in the movements and so on. But this is how the data set looks like, how one record in the data set looks like. And if you want your robot to do some simple task like the one that I demonstrate here, you need maybe like 50 or like around 50 demonstrations like this to be able to train it and make it work autonomously. Another important things that is also available in this library is integration with simulated environments. So I think many people, when they think about robotics, they think that you always deal with the real robots, always deal with like hardware robots. But in practice, a lot of things in robotics are done in simulated environments. It's much cheaper, it's reproducible, it's much easier to experiment in these environments and so on. And most of the research is done in simulations, and then on like later stages, you really move to the real robot. So this is a very important part of the whole cycle of robotics development. And yeah, again, this library, the robot library, is integrated with a couple of, with like few of famous simulated environments. Some of them like simple two-dimensional ones like this push T on the left. Some of them actually simulate the whole robot with 2 arms and trying to do like some task of inserting like one object inside another. So yeah, it's very, very interesting. You can also use some human collected data sets in these environments to train your model and validate it against some existing benchmarks. So let's say you collect a data set either in the virtual environment, like simulated environment, or from the real robot, and then you want to train the model. So the interesting thing, again, if you don't have a lot of experience in machine learning and you don't know how to train models, it's still fine. Again, this robot library provides you some training scripts where you can simply like run something like this snippet of code, just provide the data set, provide the like type of the model or policy that you want to use, and it will train your model overnight automatically without a lot of interaction. So a lot of intervention from your side. It's also automatically integrated with weights and biases monitoring service, so you can see out of the box, you already can see all these charts and all the monitoring during your training. That is very also convenient to be able to check that the training happening easily. When you train this model on the like real data set, you maybe need to specify extra like few parameters, but again, it's usually as easy as this one. So on the other hand, if you are interested in the machine learning part, in the algorithmic part, as I do, as I said, like most of my professional experience is around ML, so I was very interested to look into the details, how algorithms are working and so on. So you can also kind of go deeper and you can experiment with the policies and the algorithms. I did a lot of experiments. I tried my own architecture of the models, and to be honest, a bit surprisingly, I even managed to achieve state-of-the-art results on this 2 particular simulated environments. So I developed the like approach, a very pretty simple architecture that is much more like streamlined and simpler and smaller than other existing state-of-the-art approaches. And on these 2 particular environments, it managed to significantly beat the like success rate of the previously best approaches. That is kind of, again, a bit surprising for me, but it kind of shows that there is a lot of space for improvement. So I think it's like very fast developing area, and there are still a lot of things that you can contribute. I think most of the algorithm that I used right now, they're far from optimal, and like a lot of things can be still improved. So yeah, if you're interested to kind of contribute a little bit to the algorithmic side of this, then you can always do it, and I think there are still a lot of space for you to do it. And finally, after you train the model, you can run it on the real robot. And on this video, you can see the robot completely autonomously completing the same task. So it's looking at all the cameras that it has, and it's basically autonomously based only on the camera images, tries to put this ball into the cap, and you can see that it's usually successfully do these tasks. And on the right, you can even see that my policy is also pretty stable. So when I change environment, when I move this cap, it's still following it. It's not getting stuck. So yeah, it's pretty cool. And this is how it works for the simple problems. And of course, it's like slightly cherry picked because I don't show any fails on this videos. There are fails sometimes. Sometimes it cannot grab the ball. Sometimes it just freezes in positions like this when it's like almost put it to the cap and just freezes forever. So it happens, but at least for this simple task, you can achieve very, very high success rate. So it's pretty close to reality how it works. So yeah, this is the whole cycle of experiments that you can do. And again, you can simply do it at home. You need like $100, let's say $50, and you can start experimentation at home. You can contribute to algorithms. You can contribute to the hardware. So it's pretty fun and interesting. I highly recommend you to do it. And just before I finish, just want to say that very nice thing about this library and the community about it is that this community is very active. So if you especially like, you can follow like Twitter, but you can also join Discord of this library and see that there are a lot of developments going on. And here I just want to show you just a couple of announcements that happened like in the last months. So it's basically what was released in February. So one of them is Lokivi, developed by University of Illinois. It's basically mobile version of this ARM. So they added some platforms, some wheels, made it work with Raspberry Pi and so on, and get this robot that can also like move in space. And it's controlled by the same algorithms, so you can use the same completely like approach to train this model. Another one is Pi Zero. So this announcement of Hugging Face team actually porting Pi Zero model into the robot library. So Pi Zero is kind of more complicated edge kind of development model in robotics. I would say it like some analog of probably LLMs. So imagine like ChatGPT that instead of predicting tokens, instead of predicting words, ChatGPT can predict actions for the robot. So this is what VLA models are. So it's like a big model that takes as input your natural language commands, take images from camera, and then predicts the actual actions for the robot and manage to control your robot. So it's like edge research. It's very cool. And again, it's already integrated into the library. So yeah, this is everything I wanted to say today. So please like follow this library and different like GitHub and everything else. You can also follow me to ask any questions that you have. Yeah, thank you very much. Thank you very much for your attention.
Thank you, Ilya. I have a question, but I'll ask audience questions first. But before that, is Apu Garg in the room, please? Can you please set up and get your slides onto the screen now while we do the Q&A? Right. Questions? Excellent.
The slide where you showed the manual training part, like you had like the action and the target, right? But then it sounded, yeah, this one. Mm-hmm. I don't know, the way you explained it, it sounded like that the action is also used as an input for the trained model, but I thought it's mostly just the sensors, or I don't know, maybe you can explain that.
Yeah. So the pictures that you see from the camera and the actual state of the robot, like historical, like current state, is used as input for the model. Yeah. But actions used as target. So the model, at least like this model that I use, tries to predict, like, let's say, next 10 actions given the state and given the pictures that you have from camera. Yeah, I think you can
okay,
just
okay.
close
Thank
it
you.
and prepare. Yeah, so yeah, this state is input, actions is actually output that is trying to predict. So it's like try to predict what I will do in the next second as a person who controls this robot. Yeah, combined with camera, like camera and state are the main inputs for the model. Yeah.
Nope, maybe not.
Hello. Thank you so much for sharing your hobby. I have a question. Is it possible to prepare data set from a simulator environment and after this use a real model? What is the successful rate? I mean, like, what is the difference will be? I hope clear.
Yeah, it's a good question. And actually, this is how it actually works quite often. So a lot of robotics labs, they create this simulated environment. There is like, I don't know, NVIDIA has like very big project where they create like physical world simulated to train their robots. And this is very popular approach to actually train the robots. So you mostly train it in simulated environment, and then either without any adaptation, you kind of put it into real world, or sometimes with like some extra fine tuning, you put it into real world, and it's much easier and better. I didn't try it yet, so like I didn't try to experiment with this particular robot and simulation of it, even so there are already some of them available. But yeah, usually, of course, when you move from simulated environments to real world, the success rate drops. But if you add extra fine tuning, extra training, and like a little bit of data in the real world, it works well. So this is how it's often done.
I think there's one behind you. We still have several minutes, and we've got some technical issues. So I think this gentleman here had a question. Use the microphone, please.
I missed the beginning, but the type of tracking you can do, is that limited by the hardware? Can you only really do like event detection-based tracking, so like fully just one object and it's just whatever object's there, it has to find that one, or it can't, if you have like multiple objects, some of them maybe get obfuscated or something. Is that within the scope of what it can do, or is it detection based?
Yeah, sure. So it can do, it's definitely within the scope. It can require you maybe train a little bit bigger model. So I train it for simple tasks, and I use very simple and relatively small models for this. If you want to train it for like more complicated problem where like some objects are like obfuscated and so on and so forth, it also will work. So we probably need a bigger model. You probably need like a bit more data, but there is no reasons for it not to work. And yeah, so I try to run it for a bit more complicated problems, and it works fine. But again, when you make it harder and harder and harder, of course, success rates start dropping, and you need like more tweaks, more fixes to make it work. But yeah, it's possible. It's possible.
We've got about 3 minutes before we start the next session, in which case I'm going to ask a question.
Yeah, sure.
You mentioned it in passing, but I missed it if you expanded it. When you're going through that initial training cycle, you mentioned that it was important that something, perhaps the cameras, cannot see the manual guidance input. You want to talk a little bit about that and how that can go wrong?
Yeah, sure. So the cameras, so the robot relies on the camera pictures to predict like next actions. And the thing is that if you, let's say, just stand with this, like the leader arm in front of the camera, and your movements are on the camera, then it's much easier for robot to just learn to recognize the position of the leader arm from the picture and just repeat it, rather than understand that it needs to grab the ball and so on. So just seeing you moving the arm and learn that, oh, I just need to do the same. And then it learns to kind of mimic the movement of your leader arm from the picture, rather than like completing the actual task itself. So I've seen people like, again, in some discussions, people made this mistake and they really like trained the model and they say, oh, it is doing nothing unless I start moving this arm again, and then it like just mimic the actions of this arm. So
right, so there's a bit of learning about controlling the limbs, which is learning either way, but there's a sort of task planning that it doesn't learn if you do this for it.
Yes, Well, just much easier to replicate your actions that it see on the video rather than trying to complete the real task.
Please leave that. Yeah. Brilliant. Okay. I get. It's like with a child doing the thing for them instead of letting them struggle a bit with how to do the thing.
Yes.
So that works really well. Thank you so much.
Thank you.
All right. Next up, we have Apoorv Garg from Wells Fargo, who is going to be talking about practical learning with an open source robotics platform. Please go ahead.
Hello. I hope I am audible. So I'm going to talk about one of our product developed by an open source organization called JD Robot, and that is Robotics Academy. It's very loud and clear, and it's before moving on to the platform, I would like to introduce myself. So I'm currently working as a software developer at Wells Fargo. So it's a bank, and my project is not related to that. And I work as a technical steering committee member at JD Robot, and we have been participating in Google Summer of Code for the past 4 years. In 2022, I got into JD Robot as a participant, where I worked all around the front end of it, which we migrated from vanilla JavaScript to React. And then for the next 3 years, I have been here, and we have been working on very cool projects regarding robotics and end-to-end autonomous driving, which I'll be showing later. And I have learned machine learning from Amazon experts via a program launched in India, Amazon Machine Learning Summer School. So I got my learning from machine learning that time. And I have been part of one of the similar programs as Google Summer of Code, which built tech around government, called Code for Government Tech, which is again an open source program, which is for the tech built for the government, which is needs to be very scalable. So it was a very amazing program there in India. And then I have been ex-SD at Deloitte, Resilient AI, and TalkDog. So thank you for my introduction. So I'll move on to our key product, that is Robotics Academy. So we created Robotics Academy in mind to help researchers and students, PhD students, to learn about algorithms. So currently what happens when you are going to start with robotics, there are a lot of hurdles to just get started with. You have to install ROS, you have to have a simulator. Before jumping onto physical robots, you would really like to test it over a simulator. So one of the open source simulator is Gazebo, and so we have to set up a Gazebo. And believe me, ROS and Gazebo works very well with Ubuntu, but they have their images and their source code for Mac OS and Windows. But I think the installation takes a lot of time, because I have tried myself, and Ubuntu is the fastest way to do that. So with all these hurdles, as a student, we are trying to get started with with any of the robotics exercise. A lot of time would be get wasted in just the installation, which I think takes 70% of their time, and then 30% of the time that they would have spent on the research and trying to build some algorithms around the robot. So for that, we have this Robotics Academy platform, and we have a collection of exercises in that, along with some challenges to learn robotics in a practical way. And I'll just start this video. It was done by one of our contributor in last year GSOC, Mihir. So I'll be, I hope it's clear. There's no volume. So it's a follow line exercise. And you can see we have a gazebo there. This is the gazebo, which is showing that the car is going and following this red line. And on that, we have our own visualizations that we have created. And this is our Python editor. So what you just need to do is you just need to install a Docker image and just write one command, and that's all. You'll get this platform ready. You just need to know how to write Python code there. And we provide two libraries, which are called HAL and GUI. That are written top over ROS. And internally, we are using ROS inside of it, and all the things are connected. We have different, you can see in the green, and the top of the bar, there's our robotics backend. And then we have the world, which we have different worlds for one exercise. So you can come up with different algorithms and test your code if it's working on just one world or multiple worlds. And then you have the application name. We have several exercises, around 26. and you can see the console also. So if you want to do some terminal and check the status of Gazebo or ROS, you can also do that. And the whole UI is responsive. So we have set a reactive layout with the help of that. Like if you want to minimize the code editor, you just want to focus on the visualization part, you can do that. And we have several exercises like that, like this on different topics. So this is our GitHub link, so please check that. And okay. Oh. Yes. So what do we offer as in this open source platform is, first is simulation-based learning, which I showed you through Gazebo. Currently, we are using Gazebo, and we recently migrated into Harmonic, and there are multiple versions of Gazebo, and you really need to match it with the ROS version. So there are always some recommendation by ROS and Gazebo to stay ahead and to have that stability in your system. So we always try to do that, and we provide programming in Python. So it's like robotics, I think Python goes in hand to hand. The web-based interface that we have built, which was earlier built on vanilla JavaScript and HTML, has now been transformed into React-based and Django templates. That was done by us in the organization in 2022. And we have visualization widgets. We offer different visualization widgets for different exercises. As you were seeing when there was a follow line exercise, so the car was showing the front of the car, and that was like because, it was showing the bird eye view. That's what we call. So it was showing from the top view and was showing that the car was following the red line. And similarly, we have a human detection, palm detection, where we can see the numbers like digit classifier exercise. So there we are using actual camera that becomes our new visualization widget. So for every different exercises, we have our own visualization widget, which can help researchers and students to get the results and to test their algorithms. And this is cross-platform execution. We are using Docker for it. So you don't need to think about which OS you are using, be it Mac OS, Windows, or Linux. You can run it anywhere, and it would be very easy to just run, because you just need Docker, and you just need to run the image for it and nothing else. And we also offer with compatibility with physical robots. Okay, you all have done the simulation part, but you really want to test the cool thing, right? You would like to put the code into the robot and test if it's working correctly or not. So that is also there. You can you can load your code into the robot and test if the algorithm is perfectly fine or it was just working in the simulator, because simulator is still a simulated environment, but when it comes to real world, the things get a little changed, so you can test your code there also. And there's one that I missed, it's the top. We support hardware acceleration. We are using CUDA for that, so NVIDIA CUDA. So your system can, we use GPUs to accelerate, and it's really fast. So please, this is one of our good feature. I really like it. And so I was talking about 26 exercises, and I have primarily divided into 4 tracks of it. And first is autonomous driving. Can I know how many of you know about Waymo company? Oh, anyone has tried that company, Waymo? Okay, so it's a very cool experience. I have tried it, and it's autonomous driving. So you will be sitting in a car and there's no driver. So it's a little I got nervous, but it's very fantastic. And we have an exercise, we have recently worked on research also there, that with the help of LLM, you can just instruct a car, and the car will listen to the instruction, and it will take the prompts and will make it into actions. Like if I'm saying go ahead 50 meters, so it will check if the car can actually go 50 meters or is there an obstacle. So we do offer such exercises also in our platform. We have computer vision tasks. As I was saying, we have digit classifier exercise. So if you are putting 1, 2, it will show, okay, this is 1, this is 2. So we have such exercises also there. Yes, we do have a drone exercise also, and we are using MoveIt for building drone exercises. So it's really cool. We have this follow person exercise where a drone will be following a person. You all must seeing one follow person turtle bot here also in the exhibition. We had you doing it for drones also, and we have some service robots also. That is also one of our categories. So that, like, these are the 4 different categories that we are doing. And now I would like to talk about the intuition, like how we came to this platform and what were the things. So at our core, we have built a Redeye, which is just Robotics Academy Docker image. Everything is packed. As I said, you just need Docker to run our application. So what we have done is we have different technologies that we were expecting that the robotics person who was trying to do anything with the robotics to install all these. But we have put everything in one pack called Robotics Academy Docker image. So we are using PostgreDB, which we recently migrated from DB SQLite. And yes, ROS is at the core of it. We have OpenCV for the computer vision exercises, and Gazebo. And as I told you, we are using the web-based interface with the help of React and Django. And one of our main component that is developed by our community, that is Robotics Application Manager. You were seeing Gazebo, but if someone has worked around Gazebo, it doesn't come up like that. It's a simple it would be an empty world file. So we are creating every world file. We have Ackerman, robots, cars, and you can look at like all of this is there in our repositories available at Robotics Application Manager, and all the things that you require are there. And Ubuntu, I made the big one for Ubuntu because the base image of the Docker was on Ubuntu. That's the reason for it. So like this was the part 1, and the Robotics Application Manager is at the very core of this project, because we are using multiple different services like Gazebo, ROS, and the visualization, but they are connected by one core manager, that is Robotics Application Manager. So we are using WebSockets, which communicate via our manager, and we have this structure. Whenever you are passing the code from the Python ACE editor, it goes to the manager, it loads it in the backend, and you just see the results in the visualization, again with the help of WebSockets and the Gazebo also, which we have built using VNC, no VNC. So it's running inside the Docker, and then it displays with the help of VNC. So that's a little tech about how we have built it. So this is the part 2 of it. I just tried to make some circles in which we are telling like what's the core, how it's going. As I told you, it's the Ubuntu at core, and then we have ROS. We have installed Ubuntu first as the base image, then we are using ROS over it, and then we have our Robotics Application Manager and the Gazebo. And then moving to what are the other products that we have developed as an organization. We have Unibotics, which is an online website of it. You don't need to install anything now. You just go to the web browser and you can work with the robotics exercises. And we have BT Studio, Visual Circuits, and in the education we have this offline mode which we call Robotics Academy. And we have AI-driven robotics, the end-to-end autonomous driving with text-based instruction. That's the latest one that I worked on. We have behavior metrics, detection metrics tool as well. So this is our YouTube page. You can look at the different exercises that we build and what we do as an organization there. So please go check out our YouTube page. The links would be there. I have put some time for questions and answer. Thank you.
Fantastic, and thank you very much, because we have an exceptionally tight schedule after you, so I really appreciate you finishing a little early. So Marco, whenever you're ready. Paging Marco, whenever you're ready. Okay, while Marco is setting up, any questions on the learning environment for robotics? Here's one at the front. Oh, Ed.
Do you have Gazebo as a UI to show or something?
Sorry?
Gazebo UI to show something there?
Yes, I can show you. If you are looking at this video, this is the Gazebo running. Actually, we have installed, like the world is already configured here, and this is the simple world. And if you see at the visualization, It's like a base 64 image that we pass through, base 64 encoded image we pass through our WebSockets. So if you look at this, the car is there and the images are also getting rendered from the gazebo. So this is the gazebo here.
Okay.
Yeah.
Okay. I thought it was like you have created the one video hall of having all the code and video and etc. things. So I didn't distinguish between the gazebo basically.
No, this is our web-based interface basically. You can see everything is installed at one place and you don't need to, jump through a lot of windows. If you have worked with robotics, trust me, it causes a lot of issue if you don't have many monitors. It's at one place only. You just need to, you can also minimize this, like if you want to just look at the visualization. You are done with the coding, you don't want to look at the code now. You just want to look at the result. You just slide it over and you make the visualization bigger and you can look at it more clearly, like if you're working on small. Yeah.
One small follow-up question, and I can hand over to him. How we can add the any third-party sensor or something like that? Like for example, if I have a car which takes a U-turn or maybe which takes a horizontal parking system kind of thing, so which requires a 360-degree sensors, right? How
LiDAR sensor, you mean, like something?
Yeah, I guess LiDAR. I don't know about that much, but I think that. Yeah, kind of LiDAR maybe basically. But how can we test these kind of sensors using this Python? Is there any separate module that we need to learn or add?
Like we have a module which is called HAL that controls the robotics movements and the sensors data you will get from the HAL layer that we have built.
Okay.
Yes.
Yeah, thank you.
Thank you. We have the unusual problem of actually having time on our hands. Anybody else? Questions, comments, thoughts? Yep, microphone.
Hi, thank you for the talk. I just want to check, ask you basically on you guys have created this infrastructure to help people get started in robotics, to create like new algorithms and stuff. But what is exactly the industry trying to look for that robotics to solve? What's the current limitations, and what are we trying to solve for?
Could you please repeat the question?
Also basically, what in terms of robotics as a community and industry, like what are we trying to, like what is the current limitations that has not met the industry requirements, and how do you think that we can solve for it?
Like when we work with any robotics, like maybe there is one algorithm written already. Like we all know a follow line exercise. I think it's a very basic one. You already know an algorithm for it. Maybe it's something you can work differently, maybe with a different approach. So that's what we try to aim. And we also have some PhD students. So they extensively use this product to learn robotics. So for them, it would be like the same algorithm that they might have learned in the classroom, and they want to test it out. So that is there. And for the industrial purposes, we do have different tools, and you can see like, no problem. We have like behavior metric tools. I think that is something you can check out. That is more towards new like new standardization of robotics. So you can look at that there. Yeah. I hope I'm able to answer your question.
Yeah, thanks.
Okay, thank you.
We could probably even squeeze in one more while Marco sets up, if there's anything else anyone wishes to raise at this moment. Going once, going twice. So, okay. Thank you very much, Apoorv.
Thank you. Thank you.
All right, we'll pause for a couple of minutes. We have some odd scheduling, but I'll start Marco at 20 past the hour. Marco is part of the FOSSASIA team and responsible for a chunk of the video, both in-room and support for the streaming and recording. So quite apart from an interesting speaker, he's also a rather important member of our team. Yeah, I'm sort of cautious about running too far ahead. Oh, I see. Next speaker. Okay. Oh, I get it. All right. There are many moving parts. Please don't worry about it. Marco is going to speak to us apparently about robot jazz. I think that's what all that means. Thank you, Marco.
Yeah, thank you, Roland. All right. So the story that I'm telling you guys today is about the robotics operating system. Who here knows about the robotics operating system? Can I get hands? Okay. Some people don't. Okay, so basically, the robotic operating system is not an operating system. But when it happened, they gave it that name because they were like, oh, we have this robot here, we need something to run it, right? So we have to come up with an operating system. But in the end, this is not what happened because they didn't want to reinvent the wheels. There's operating systems, so you run some Linux machine, or nowadays you can run it in other stuff, but mostly works on Linux, and then you just run this ROS on top, which is something that allows you to create your robot software on top of it, right? Just to put everyone on the same picture, in the robotics world, there's this programming pattern that is called component-oriented programming. It's very widespread, and pretty much everyone uses this. And you can think about it like microservices, and it's basically you just create these small binaries that talk to each other, right? So you can think of like, I have a camera, I put a binary that takes the images, then I have another binary that takes the images from that binary, calls through the network, and do some processing over the images. That's a small example. So the story of today is about this ROS operating system, robotics operating system has a wide range of packages, and there's something that we call the ROS boss, which is basically the guy who is in charge of a certain release, right? So I'm going to talk about it because I was the ROS boss for our latest release, which is Jassy Jalisco, and that's the name we gave it. And it's quite a complicated process, and I guess it's interesting for not only the robotics people, but anyone that wants to put some software out there that has a lot of clients. So yeah, some justifying a bit why this is important and why it's worth talking about it. We're going to give out some numbers to see that it's not as easy as some other software, right? So as I said, the robotics operating system is a highly distributed software, and because of these binaries and because of the nature of it, everyone in the world can create their own repo, can create their own package, and can put it out there, right? And we will take care of the release of this package, and we put it in the build farm, we put it in the repository, right? So to give you a small idea, I took these pictures from, this is our repos, and I think you can see that there's like almost 2,000 packages for Humble, which is the previous release, Jassy. We got 1,500 now, and our rolling release has 4,600, almost 7. Yeah. So that's a lot of packages. There's also a lot of people using it, a lot of downloads. I'm not going to go through the numbers. This is also on the Discourse if you guys want to have a look, and also a lot of companies using it, right? So you got to be careful on what you do, or what you put out there, and you wanna do it timely. You wanna do it properly, right? And then again, I did an overview of what is ROS, but I want to go a bit more into detail of what is really ROS, because this is what we are trying to distribute, right? So we usually refer to ROS as this plumbing, which is the networking that I just talked about to connect these nodes that they talk to each other. There's also a bunch of tools that we put out there with this plumbing system, but they also a lot of them come from the community. And then you got these capabilities and ecosystem that are actually mainly provided by the community. So the entire community do their own thing. So there's people focus on navigation, there's people focus on perception, there's people focus on control, there's many other parts of the system. So when we talk about a release, how much of that is our work, how much is not, right? So if you look at the SKCD example in the ROS, adapted for the ROS ecosystem, we have this thing that we call the core ROS packages. And those are the small subset of packages of the ecosystem that we actually actively develop, actively support, and that we actually care to put out there with a release. The rest of the entire thing we sometimes refer to it to user packages because they are developed by users of this core of this core set of packages. But we also help these people build the packages. There's tooling for them to release and put it out, and we also help them put it out there into the repo. A bit on the releases. So basically, there's this thing called RAP 2000, which is just a write-up that we do in the write-ups that we do in the ROS ecosystem, and it basically defines how our releases system work. So we basically put a release yearly, and we alternate between LTS and non-LTS. LTS, they get like 5-year supports, non-LTS get 1.5 years. And then we have different support levels. So different support levels means, like, for example, Ubuntu is tier 1, it gets more testing, it gets the bug fixing is prioritized. But then if you go down into macOS, this might not be the case, right? And then we have different target platforms also for the different releases. And then we have the Rep 2001, which basically defines the variants of the packages. So we have this variant that I'm not going to go through, but the most important one is the desktop variant, and that one includes all these core packages that we've been talking about, right? So as a ROS boss is one of the key parts of the release process. And then thanks to the very nice process that has been put out for many years, we are able to put the entire desktop variant out there on the day of the release, which actually was not the case before. So if we look at the entire spectrum of releases that have been happening, you can see that lately, at the beginning we were doing a bit more frequent releases and a bit more here and there, but lately they are coming out on May every year. And we have this release called the rolling release. So basically everything that is lately developed and is new goes into the rolling release, and then it can be backported, and then at some point we just branch out of the rolling release and we create one of our more stable releases, right? And we see a bit more about that. And more on the ROS bossing side, what are the responsibilities of the ROS boss? So you can see one of them is choosing the name, probably one of the most important ones. Then you port to a new Ubuntu if this is needed. So Ubuntu is the primary platform that is supported by ROS. So that's the main target initially, and then we take care of the rest. Then we do an initial branching of rolling, and then creating and coordinating testing of this branch now, and then making the actual release, and then some after release work, right? So afterwards, you, as a ROS boss, you compromise yourself for the life of that release to make sure that it is alive and the new updates keep coming, right? So for example, for Yasi, it's an LTS release, so I will be working on it for the next 5 years. Infrastructure. So this is made possible 100% by the infrastructures that we have. It's an amazing work by our infrastructure team, and I'm going to do a bit of talking about it so you can get an idea of how it works. So we have something called the ROS distro. It's a repo on GitHub, and it basically contains a YAML file. So in this YAML file, this YAML file is basically the source of truth. You can think about it as a database for all the packages of a certain distro. So each distro in this repo will have a YAML file, So I think the picture is IDON, which is the release right before Jazzy. So you can see that the packages will be listed there, and you have information about the package, like the source branch, documentation, repo, the URL of the different repos, and all that. This gets automatically updated by a tool called Bloom, and we'll talk about it a bit more later. And the build farm actively pulls these files and then uses this information to basically build the packages automatically. And now we talk about Bloom. So this is one from the user perspective of ROS, and someone that wants to release a package that has done certain work on robotics, and they say, oh, this is useful for the community, I'm going to put a package out there. So basically this is a command line tool that you can, you have a repo, like in this case, we have RCLCPP, is the example. And you say, I want to release this package. So you basically create your package infrastructure, which is basically an XML in your repo. You put some information there, you put the version, you put your changelog, and then you run this Bloom command line. And what it does is create this GBP branches. So you have a release repo, and then in this release repo, it uses this format where release branching and platform-specific sources get pushed, and then it actually creates the pull request to the previous file that we saw, the ROS distro file, and then this pull request is the one that will integrate the information about your package into the distro file, and then the build farm will continuously read this distro file and build your package, and it will appear in the repo by some infrastructure magic. And then the ROS2 repos file, it's basically a subset with some information about the actual packages that a ROS boss should care more about, and the ROS core team also cares about, which is basically the desktop variant that I was talking about. So it basically contains right now about 106 repos and 358 packages. So these are the ones that the core team of ROS will be actually actively developing, right? It contains latest version of each repo for a certain distro, and it also contains every single sync. So periodically, packages that get updated and get added into a certain distro, they get synced, and then this is reflected into this repo through GitHub tags. So this is the picture of the build farm. It's you guys can access it in build.ros2.org, and it runs all the jobs for all the ROS releases, for all the architectures, for all the supported platforms. Basically, as I said, it goes, reads the ROS distro file, pulls out the information, builds the source packages, and then builds the binaries, and initially it sets them into a test repo, and then this test repo is responsibility of the ROS boss to go check this test repo and sync it to the actual, what would be the production repo, right? And put it out there. There's another instance of Jenkins. This is the CI. So the ci.ros2.org is what we use, and we use it to run tests, all the tests for these ROS core packages. So this ROS core, every time there's a change on these ROS core packages, we will run and make sure that it's not breaking any tests, right? So we will run tests for regressions, put it in the PR itself, and then if it doesn't pass the test, then we don't merge it. We figure out what's happening and try to fix it. One interesting thing Steven likes to say, which is the guy in charge of the infra, that up to his belief, this is not this one, but the build farm is the biggest public build farm that he has ever found out in terms of packages and all that. All right, so let's talk a bit more about the process itself. once you become a ROS boss, what happens? So there's a process board that is a bit more for the ROS boss to follow, and it has all the steps in GitHub issues that we actually go closing as you do them. And there's more, both are public, but this one is more like to the public, this one is more for the ROS boss itself to follow. So these ones are the rough schedule of what is happening and when it's happening, so people can read what to expect. And these are the steps that we usually follow. As I said, one of the most important one is naming the release. So this one happens quite early. Usually the name of a release is announced on the same day that the previous release happens. These releases are named in alphabetic order, and they use an adjective and a turtle species name as a general rule. So what we do is we put out a post for the community to suggest adjectives and suggest turtle species with a letter that corresponds to that release. And the thread goes on. We put a lot of, the ROS boss has to write them down, put them together, and then there's a discussion on the ROS projects committee, and then a name gets selected. Then there's a logo commission that usually is done related to whatever name the release had happened. And then at some point, there's a date where we freeze the rolling release. And then these rolling packages might need certain updates or fixes. So that's the time when we do it. So one of the biggest examples is when we need to port the entire release to a new Ubuntu. So if there's a major Ubuntu coming, then that is a work that we might have to do. There's the branching of this release. So once rolling is stable enough, then we just branch it into a new release. We give it a name, then we run some tests on it, we do a release. And then the post-release work that I was talking about is just basically taking care of the release for the life of it. This is a bit more of a visual thing. You can see there's the rolling release that we have going there. And then we port it into a new Ubuntu if needed. So in the case of Jassy, it was needed. Much also like there's also other portings involved. Like so I know like we had a lot of work with linters that year. We had a lot of work. Also Python was changing version. So these things might also have to be updated in the rolling release. And once you have that for that freeze period of time, then you just create the branch. Okay, then after that, what we do is we have something that we call the tutorial party. This is something that we've been doing lately that is actually quite cool. What we did is we got all the tutorials that we had, in the documentation. We created a script, and then we created one issue for each tutorial, for each supported platform, and for each architecture. And then we did the permutation of those. We put all these issues. I think it's about like 600 something issues. And then we put it out there. And then we told the community, hey, we have this new release coming. Please go test it out and tell us what is happening, what you get there, right? So that's pretty cool. The response on the community was great. A lot of people engaged, like running this on different platforms, Mac OS, Windows, Linux, Red Hat, whatever. And we really fixed a lot of bugs, and we actually improved the quality of the release on day one. Because one of the main things that happens in the when releasing ROS distros is that everyone is very skeptical of using it the first day, right? Like everyone's like, whoa, I'm not going to run this on my production robot, right? I don't want it to kill someone. Let me wait a few years until this is getting into a stable thing, right? Like, until people have been playing around with it for a while. So this was a big effort on trying to improve that situation. Because then the other problem is that by the time people start using it, then it's almost the end of the life of the release, and then the end of the life of the release happens, and then people are like, oh, you know what, I'm not going to change again to another release because I just started using this one. And then they end up using a release that is not supported anymore, right? So yeah, there was a really good response on this. One thing that we do is to the top contributors of this test, we give them swag. So with every release, we put out a bunch of swag with the logo. It usually, it only stays on the store for the life of that release. So once that release is gone, the swag is gone. And it's on spring.ros.org, and they sell it, and the profits go to the foundation. And yeah, for the tutorial party, I think this year was like the top 10 contributors, they got some t-shirt out of it. Yeah, and then it comes to release day. Release day, you have to mark the distribution active in a few places, ROS distro, index ROS, You run this sync job that moves all the build packages from the test repo into the production one, and it's available to everyone. You do some tagging in some of the repos to mark that those releases in the ROS distro files and these ROS2 repos and all that. And then you make an announcement post on Discord, and everyone can start using the release. So for Jazzy, we released on May 23, which is Turtle Day, 2024. It's an LTS. I'm bounded to keep working on it until 2029. We released 1,732 packages on day one, thanks to this entire amazing infrastructure. It supports 3 architectures, 6 different operating systems. It has 211 contributors, and we got like 29 tutorial testers. And as I said, we have to keep maintaining the release. So what we don't do is we don't break API for the core packages. So we just, all feature development will go into rolling, and any improvements that are breaking API, they will just stay there and go into the next release. But if it's a bug fix and it can be backported, then it will get backported, and these things will update packages into the release. The supported platforms, Ubuntu, Windows are tier 1, tier 2, Red Hat, and tier 3, macOS and Debian. Yeah, and then we did the release. We put the post in this course, which is our main means of communication, and that's it. I want to just remind everyone that we have our ROS conference coming not so far from here in Singapore. So if you're interested in more ROS and more robotics, this is a really, really interesting conference to attend. There's a lot of people, a lot of folks, and a lot of things going on in the field. Yeah, thank you very much. Here's a bit of links and information where you can find the ROS project, Gazebo, OpenRMF, which is the things that we spend our time on. And yeah, I think I have a few minutes for questions.
Very cool. Thank you, Marco. May I have a round of applause. Rich, please set up. While Rich is setting up, we've got room for about one question, if anyone has one, before I start making cracks about jazz. No questions on the task of building an operating system? Excellent. So, Marco, if I understand you correctly, I have 5 years now to make jokes about jazz. Is that correct?
Yeah, I think you have about 5 years because it's already been like almost 1. So we almost get into the freeze time for the next release, Kilted Keiju, the K1.
Right, it's already in, yeah, I understand. So in that case, I have while this is not happening, one more question. The turtle, is that like the logo, because of the logo turtle?
Yes, so one of the things that we have in one of the initial, the tutorials that we have for ROS is based on logo. So it's basically a little turtle that you can move around, and the way you do it is you do it using ROS nodes and sending messages and all that. So it's an introductory tool for people to learn how to use ROS. Is this little turtle, and is based on logo.
Wow. The logo turtle was from the 70s, I think. So things have long histories. Okay. Rich, I think it's fine to do it a bit yellow if that's okay. It's a 5-minute talk. I think we'll just run with it. In fact, given the time, I will ask Rich to say, go.
All right, thanks. Hi, my name is Rich Sauls. I'm here to talk about Quick TLS. This is a fork of OpenSSL. We want to eventually turn it into an to an Apache project. Yeah, tell you what it's about, and looking for possibly volunteers, people who want to join and help. I will be less than the time I have available.
That's all right. Let him slide.
Okay, so why are we doing this? For the past year plus, OpenSSL has been doing Quick. We don't want to implement Quick. It's moving very, very quickly, as it were. And instead, we want to enable other Quick implementations to use an OpenSSL-based stack. Google's Quick uses it. Microsoft's Quick, which is MS Quick, both of those are on GitHub. There's also NG TCP, also uses this one set of APIs. So we want to provide that set of APIs. We offered it to OpenSSL. They were in the middle of doing their first FIPS release, so they decided to wait. They decided to wait, and then after about a year, they said, no, we're going to do our own Quick implementation. So we felt a little put off by that, but anyhow, we want to enable Quick. The other point is they're spending a lot of resources on doing that. There's more to cryptography and TLS than just Quick. So we want to implement these other things that are also there. They do have a project to do post-quantum crypto. We're also doing it. We're collaborating with other forks and so on. Finally, we want to use a modern code base. OpenSSL, LibreSSL, Boring SSL, Quick TLS, they're all written in C. If you're going to start from scratch, not the language you would do something in, you might use Rust or Go or something like that's more memory safe. But we have this installed base that we want to enable. So we're using C99 and POSIX for our base. Quick TLS has been around for a while. It's been around for about 4 years. It was originally a project between Microsoft and Akamai. What we did is we ported the classic or the standard Google API to enable Quick. It was the de facto Quick packages. It was not a standard. It was just everybody used it because Google came up with a set of 12 functions, and all the other Quick stacks started to move to that. It tracked 1.1 and 3.x releases very regularly. 1.1 is now out of support, so it's sort of frozen. And we stopped doing it with OpenSSL 3.1.7, which is about 2 years out of date. We had preliminary patches, but we never released them. OpenSSL is about to release, hopefully next month, 3.5, so it's behind. Now what we're doing is we've made it a full fork. We didn't want to, we had to. We pulled down security fixes and other changes from OpenSSL. They're all Apache licensed. I did the work to make OpenSSL Apache licensed. A key goal from Akamai's point of view, and which will always be, is that the OpenSSL FIPS provider will still work. So if you want to do TLS and be FIPS compliant, FIPS 142, 140-142, 140-3, it'll all still work. We will do regression tests and make sure that that works. We're also removing silly things. For example, one of the OpenSSL developers really likes VMS. He's otherwise a nice guy in spite of that, but he really likes VMS. So we removed VMS support, and that was about 20,000 lines of code, cut and pasted in all these bizarre places. Yeah, it's yes, you're laughing. We removed a whole bunch of other old platforms, Borland C, things like that. We removed about 12 configuration options so that it's a lot simpler and easier to configure. For example, you can't turn off elliptic curve and you can't turn off TLS 1.3. I mean, the whole point of using a TLS stack is you want to be current, you want to be secure, so we don't have this unencumbered by an installed base concept. We're addressing performance. OpenSSL 3, when it first came out, was amazingly not performant, so much so that HA Proxy and Nginx said we can't use this because it was just the more threads you got, the slower it got. So there's a number of performance changes we want to make. We also have close collaboration with the other projects. LibreSSL, which came out after Heartbleed and was a fork in anger, if you will. They said, no, we're going to use, we work closely with them. They've actually contributed. A guy named Theo Bueller reviews many of the pull requests that we make and so on. Also, we are close collaborations with Boring. So, for example, when we do post-quantum, we're just going to pick up the Google code rather than the OpenSSL code. Upcoming changes. We want to move to, you can't build OpenSSL without using Perl. It's amazing. It builds this whole big, huge makefile, which is impenetrable. We're converting to use CMake, which is a big win. There's a bunch of interesting changes we have to work on to do that, but we're using CMake. We are going to add post-quantum crypto. We'll have it before OpenSSL comes out with their release. But then if you want post-quantum FIPS, you can use the OpenSSL provider. We'll probably look at Clang Tidy, running that over the whole system so we get consistent formatting and get static analysis. We'll also do encrypted client hello, which is a way of hiding from the network who you're talking to, so that you can't do tracking based on what's called the SNI extension, server name extension. There's other things we want to do too. We have about 24 issues open. We're trying to do everything on GitHub and public. So we need you. We're looking for people to help contribute to the code. As I said, we want to make it an Apache project, so we need to build up a community of developers. If you're interested in just Apache governance and working on that, we can do that. If you can write codes or comment or look at codes or comment or documentation, we can also take that. Sorry about moving this. The two links here, Quick TLS, it's on GitHub. There's a Quick TLS OpenSSL. There's a README that says don't use this one, go use the other one. There's a mailing list for people interested in talking about how the project will be set up. Or you can get in touch with me. I'll be around here for most of the morning, at least until the t-shirt's open and I can claim my t-shirt. Or you can just email me. I'm happy to take questions, comments, or that's it.
Thank you, Rich. Wow. Yeah. Sort of involuntary archaeology. It's like, really, VMS? That's in Perl. I mean, it's a sort of museum on wheels. Right, next speaker. Can I please get you to set up now? I want to start you in about 3 minutes, so we've got time for one question that isn't one of mine. Anybody else involved in TLS? Concerned about it? No? Stunned silence. All right. This is the plumbing that everything is secured by. Please do not ignore. Thanks, Rich. All right. So, next up, we have Grimmer Kang from Fireflies talking about Switch 5. But that's okay, we've got a couple of minutes. More of the Macintosh daylight setting. No doubt someone who understands Macs can make that not happen. You've got daylight or light compensation turned on your laptop, just turning the screen yellow.
It's okay.
I think it's fine, but it's just...
It's fine. It's a confusion between the screen and the projector.
Here. Got it. Okay. Yeah, don't stress. The recording is fine. It's just this screen that's
Robotic technology is here to help us, I guess. It's John. This is the most complicated. All right. Huh? Back 30. Oh, you want to change the?
Nah, that's not right.
Yeah. Okay. You have the floor. Please go ahead.
I will start with.
Yes, yes. The microphone.
Hello, hello. Okay, I will start this today presentation. And give me 1 second. Sorry. My name is Grimmer Ken. I come from Taiwan. I also work at Fireflies.ai, where we are trying to build some online meeting AI power note-taking tool. And today I will introduce my side project, one of my open source side project, which is called Switch B. And I built it 2 years ago and use it in my daily workflow. So I'm very excited to share it with you today. So here's my GitHub. You can check out. It's agenda. So I will introduce the two main features. The first one is we can it's called instant project switching, and we can use this tool to quickly launch the right VS Code window. And this is the app store link I released 2 years ago. And the second main feature is the AI integration. I try to integrate some AI feature within this month. And it's also using LM and Tropic API key-based. So you will not, so your cloud subscription will not limit this feature. And it also is fully customizable. And in this presentation, you can learn. Hello? Oh, sorry. In this presentation, you can also learn how to build some Spotlight like application with Electron framework. Also, you can learn how to publish it to Mac OS App Store. And also, you can learn how to integrate LM APIs in your desktop application. And here are two problems and scenarios. The first one is when your VS Code is running, and sometimes you want to quickly switch to the other project window. And in this case, you have two options. You can use some built-in command like Control R, and to quickly launch some this quick switch view to select the project you want to launch or switch. But it's too small. It's a built-in feature. Or you can use some this Mac OS built-in command to navigate to the previous one. But the second problem is if your VS Code is not running. In this case, you can choose maybe use your terminal to launch this VS Code, or you can choose something that, or you can move your cursor on this VS Code app on your dock and choose the right project you want to launch. But it's a little slow. So my solution is I try to build some Electron application running in the background. So we just need to press this command Control R to quickly launch the Switch V launcher. So I can demo here. Give me 1 second. For example, something like this. And then that's all. I finished the first stage of demo. So it's very instant. You just I use this command hotkey shortcut to launch this UI. And here we support two types of VS Code items. The first one is the project folder window. The second one is the VS Code workspace. And inside this feature, we also supply another sub-feature that you can select your preferred working directory. And after you select this working directory, you will preload this list, become some green items. So it's another convenient place you can select your this preferred folder. And you can also clear this icon to quickly launch the switch V as well. It's a technical information. So the first issue we need to solve is before we can quickly launch this project window, we need to know the history of the people they opened before. So the trick I use is I build a VS Code extension. And this VS Code extension will try to listen the open window event. And so when people open the VS Code window in any way, you will send some information to this Electron application. And in this Electron application, there are some three components. The first one, UI layer. The second one is the main process. So in the UI layer, we have the Relay application. In the main process, we have some built-in server. So this server will get this HTTP RESTful from VS Code extension. So you will store the recent open window history. Yeah, after that, we already got the history. So whenever people invoke this shortcut, this shortcut will notify the main process, and it will invoke the UI layer to show the UI, and then the UI will send some request to this server running in the Electron application. So it will send this history to the UI layer, and UI will show the list, so people can select the item from the list. So after some people create some item in the list, it will invoke some IPC command signal to the main process. And this main process will get the signal that you need to launch some VS Code project folder. So in here we use another trick that we will invoke this trial process and to invoke this command to launch the VS Code window quickly. There are some main entry files. Anyway, you just need to remember when you build Electron application, in the first level of entry file is the forge.config.ts, and you will try to get some webpack config file. The first one is the main process is ready config file. The second one is the renderer config file. So along here, you can also set some entry files regarding the UI layer. It contains HTML files and JavaScript files, and also another preload of files. And in the main process, the main.ts, you also need to control some UI component. Sorry. Okay, sorry. So you also need to set some OS native UI components. So for example, you need to import some app from this Electron. And so after the app is ready, you need to create some browser window. And you also need to set some app. For example, we need to hide this app initially. And you also need to create some thread. UI is related to the main OS menu bar item. So this IPC is a very key important part. So anyway, the first key file is the preload.ts file. in this file, you need to set some event, and also it's a bundle copy function. And after this, your URL, React, and also your main.ts, they need to implement this event emitter and event copy handler. And this is some keynote when you, because we need to make this app running in the background, so we cannot call Windows star show. And also, what I use Prisma is the DB ODN to quickly upgrade the SQLite read and write. Also, another tiny part is we set some app version by this around here. The package.json there's the version field, and there's some trick about the auto DB migration. So the trick is I set some when the app running start, you will compare some file. The file, so you compare the version in this file. If the file does not exist or the version is not same, you will try to automatically trigger the migration. And if it's the same, you will not trigger the migration. You also need to handle some paste variable when you bundle this package app. There is some trick to debug this SQLite. You can use the Prisma Studio to see the SQLite database. And this is some many detail about the packaging and package. And anyway, you just need to remember there are two. The first one key point is the plist, and we need to set two different plist. There is a parent one and child one, and that's because for the normal Mac OS application, usually there's always one plist, but in the Electron we have multiple binary files, so we need to set more than one plist to set the requested permission. And you just need to after that you run some step and share script to bundle this app to the, and after that you can choose submit this your app to Mac App Store, or you can submit it to the test file, which you can distribute it to some beta user. And also there are some tips to debug this package app. For example, you can set some log in the menu bar item. Also, you can directly execute this the file to track the log, and you can also set some dev tools. And one more thing is cursor integration is done. And also, I borrowed some idea recently. I try to read the building VS Code and cursor SQLite instead of building our own SQLite file. And this is from request. And this comparison with request search recent part, this feature. And this post is up extension. And also, there are some cons, so you can choose using request or this switch B. It's another big feature. And anyway, I just built this AI assistant feature recently, so I try to run it to copy. And problem 3 is sometimes you need to feed your code or selected text to your AI to get some insight or feedback. So anyway, the process is slow because you need to select content, copy, open your either ChatGPT or cloud desktop. So I try to build another feature so I can demo it now. For example, I can choose this code and then copy and quickly launch it, and I can go. Sorry, become Chinese. Because I'm from Taiwan, so anyway, it's a quickly select code and get the insight. Yeah, and we can define your API code here, and there's also another some feature. You can support inside split mode or selection mode. Selection mode is when you define your constant prompt as empty. You will try to do the simulation, but without automatically generating the insight. It's the technical implementation. It's very simple. We just when you select code, we will try to read the clipboard content and you will send this selected text into the this file. This file in the main process will try to invoke this LN API, and also you will enable the stream mode. So from the L1 API, so in this JavaScript async iterator, you will for each delta chunk data test as a response, you will try to invoke some IPC, send this every delta in the renderer UI there. And one more thing is I also create another feature. So we can use another shortcut to import the TripGT like desktop application like. So something, yeah, very quick, and yeah. And this is a technical learning when we implement this feature. Anyway, the tech way is trying to build.
We're at time.
Okay, and then we can skip this. We've already done this one, and yeah, thank you for all the attention.
Thank you so much. I have never spent time inside tooling, so this is a bit outside of my expertise. Questions? Firstly, Matthias. Is Matthias in the room? Okay. Matthias, there you are. Matthias, can you please get your slide set up? Sort of now. While Matthias is setting up, any questions for Guma? Yes, go ahead. Our speaker is fleeing the stage. No questions? All right. Give us about 5 minutes.
I've been working on recruiting the speaker to replace a missing speaker. Oh. So that's also happening in parallel discussion right now. Oh. So it's all happening, it's all fine, the show continues. Absolutely. I have the distinct impression that you and I have exchanged.
That's a problem when you get a history that's too long, right? You can't even remember.
Laptop screen voodoo. It is indeed the, let's go with the most unpredictable part of the talk. All good? Ja.
Dat is interactie tussen je laptop en het scherm. Die denkt aan redshift en zo nachtlicht.
Oké.
Als je dat kunt uitzetten.
Geen probleem.
It seems that our screen and Macintoshes don't get on, which is why we're getting a run of yellowy looking presentations. You're going to try and turn night shift off?
Less warm?
Oh, well, that's pretty cold already.
More warm?
Maybe more warm?
Ask what the show
You can't just turn it off?
Sorry?
You can't just turn it off? I'm not a guy. Unless you have like color pictures where it matters.
Yeah, let's go. Let's just do it.
Right, welcome back. So, who have we got now? Matthias from... I've messed up my screen, hang on.
I can cover that part.
We'll do this properly. Matthias from Do It?
Yes, correct.
Excellent, excellent name. To talk just about smithing and graphing LLMs. It's a very positive sort of name. I think it's... Do it now.
Do it, I'm gonna do it.
Go ahead, Matthias, thanks.
Thank you so much. Cool, you can see my slides. They're a bit off color, but I think that should do. So, good afternoon, everyone. Very excited to be here on stage, doing something that's dear to my heart, meeting community and talking about open source. Yeah, I hope everybody is well rested. Grab a coffee, still alive, day 3. It's quite a long conference, so let's dive in. The talk is quite light. I hope it's a bit like a digestible dessert for everyone. So let's have some fun. I want to talk a little bit about myself first. I'm Matthias. There's a picture of me. I'm from Belgium originally. I moved to Singapore. I'm working for Do It, but that's the boring stuff. What I want to talk about mostly today is a little bit about, I guess, what everybody is doing today, a journey into the Gen AI world. And it started very skeptical for myself. I was like, there's another buzzword, don't really want to get into it. But at the end of 2023, my manager kind of asked me, now is the time, you have to do it, no more choice. Look into it, what is it, what's going on? So up until that point, my exposure to the field and everything buzzwordy was quite limited. I didn't even play with ChatGPT. And actually the first thing that happened was one of my friends taking this picture on a trip. He's a brilliant photographer and he likes technology. So the first thing he did after with this picture was this. I don't know if you can see, but it's basically the same picture, but me as a knight. So obviously I was a bit skeptical. I was like, okay, this is what the Gen AI stuff is about. Maybe I'm actually not that interested. I tell my manager I do something else. But okay, we're 1 year later. I delve a bit deeper and found some spots that I actually like, and produced a few talks about it to share with you guys what I like about it and maybe could be useful for you as well. So yeah, that's the first thing I did. Is like, okay, I can do this as well, and it's really useful, right? Kidding. So you're probably wondering what this talk is about right now. But before we dive into the real stuff, one more story time. So in the summer of 2024, I went to Okinawa. Anyone from Japan here? No? No one from Japan? Okinawa is like the southern part of Japan, right? Beautiful, beautiful place. I can highly recommend going. So I'm really into the scuba diving, and one thing that we're allowed to do as a company is spend some of our days to do volunteering for something we care about. And I care about scuba diving, I care about the marine environment, so I went to Okinawa and I tried to do some things that help the environment. And I've taken this picture there, which is me doing coral planting. But as you might know, traveling in Japan, I don't speak Japanese. I don't read Japanese. It's not that easy to find stuff on the internet. It's not that easy to browse websites. So it was a bit hard. So I was like, okay, maybe if somebody else ever wants to do something similar, let me make it a bit easier and combine it with something I've been willing to do for 10 years as well, is create a blog post and create my own website. So after 10 years, 2024, I finally did it. I expect applause for this at this point, but I created my website and the first blog post. And I was lucky enough to have a friend buy the domain name, basically myname.com, and he put up this first, like it's gone now, so we can be happy about that, but he found a picture of maybe 20 years ago of me and put some interesting stuff that is now gone, and I'm happy to say it looks now like this. And that's basically the topic of the talk, is this blog post and all the stuff that came from that. So if you would go to the website and you would look at the blog post, you would see a lot of stuff about marine life and the things that you could do regarding marine life in Okinawa. But you might notice that the captions become a bit repetitive towards the end, because I took some pictures, I wanted to describe them, and yeah, at some point my mental bandwidth was like here, and I started doing just like OIST, which is the name of the university I went, projects and like OIST campus, and yeah, it was getting a bit not that descriptive. So that was about the same point I was doing some LLM stuff, and I decided, okay, let's see, take this problem and take this potential solution and mesh them together. So, topic of the talk, I think that's kind of what I covered in one. We'll look at how I solve my problem. Then we'll look under the hood, the technologies I used, and that maybe can be inspiring for some of your projects. Then some takeaways and maybe some time for questions. Yeah, we'll see about that. I think 25 minutes might be a quick one. Cool. So I was planning to do this from the presenter laptop, so I took mostly screenshots and videos instead of having live demos, but it should be pretty similar to the real thing. So this is what my website looks like. In VS Code, we have a source folder. It's based on 11t, and you can see the let me see if I can find my pointer. You can see the landing page, which is a template, and then the blog post template, and then the actual content is a markdown file, which is, yeah, you're all familiar with markdown, right? A little bit further, we have the posts and then the pictures. So there's quite a few pictures in there. The images, and this is the one you should recognize. So that's the structure of the website, and that's what the version 1 was. And yeah, so how did I solve my problems? Basically, when I was doing my journey into GenAI, some of the resources I came across, one was Andrew Ng's talk on agentic systems and what was going to happen in the next year. I highly recommend this talk, and he kind of tried to predict what was next at the end of 2024. So that was first inspiration, and the second inspiration I also highly recommended was BEAR, which is the Berkeley Institute for AI, releasing a blog post which was closer to my heart because I'm an engineer, I'm not a deep learning researcher, talking about the shift from the power or the importance of a model, like whatever Google's and the AWS and now DeepSeek is training, and what we are, maybe it's kind of hard for us to do, to like building a system around it and making it useful. So a compound AI system, they call it. And some of the tools that I was interested in were mentioned there, like LangChain, LangGraph, and LangSmith. So that's what I decided to explore, and this is where we should see some action. Okay, this is a different kind of demo god situation because I'm just gonna try and play a video. Yeah. Hey everyone, so we're here. Okay, I'm gonna see if the. I think we. Okay, there's audio, but maybe I'll just talk over it. I'm gonna come off stage and watch with you guys. So, yeah, this is the agent that I run with a simple Python script, and you saw the picture, and it's starting to write logs. So, yeah, first thing it's gonna do is summarize the blog post. So the blog post was about 30,000 characters, but that was too long for the model that I wanted to use because I'm running Gemma locally. So the first thing is a summarization using Gemini, which summarizes it to 1,700 characters and kind of describes what I wrote up in the blog post. That's the result there, and it took about 10 seconds. Then I use another model to first encode and then describe the image, which generated another 1,000 characters. So I don't know if you can see this. Image shows a hand holding a small piece of coral attached to the concrete block with a metal wire. There's a Belgian flag, so yeah, that's kind of that one. It's a bit off color, but. And then it kind of also captures the context in which I'm describing the picture. So it talks about the image perfectly illustrates a blog post focused on marine conservation efforts in Okinawa. And that description took about 10 seconds as well, 8 seconds. And from this, it started generating some caption proposals for that picture. So we have 5 caption proposals, which you can see there. Witnessing the birth of a coral reef, planting a seedling in Okinawa, a symbol of hope for marine conservation. Yeah, etc., etc. I don't know if you can. Yeah, everybody's quite close, so that's good. So this is where the feedback loop starts. Either we have some proposals, but you might not be happy with them, and I still wanted some control over it. And this is where I can either say, number 2 is going to be the caption that I want to use, or I give basically feedback to the LLM, like, do something else, this way or this way. We swear we can give it some feedback. So I think I asked for shorter, because that's a long caption. And then I got planting Matthias a small coral, a big step for Okinawa's reefs. Witnessing hope bloom, planting a coral seedling in Okinawa vibrant waters. They were not great in my opinion, so I think I did some more refinement. Yeah, make it more. I wanted something funny and asked for some smileys. So I came up with planting Matthias. This little coral might be small, but it's a big step for Okinawa's reef, which is not funny at all. Yeah, I think the first attempt at funny failed. And it kind of stuck very close to the initial captions it had. So I think I did another round more funny. This little coral might be named Matthias, but he's about to become a reef rock star. I mean, yeah, sure. I think the second one was the one I chose, yeah. Yeah, so the one I went with was planting coral seedlings in a serious business, but I'm pretty sure Matthias is judging my dance moves underwater. I mean, you can be happy about this. I don't know if you guys like it. Yes? No? Yeah, I was happy enough with it. So basically, I chose 2, it writes it to a file, and then it can integrate it into my blog post, and that's kind of end of demo. So, I hope you're now curious, like, how I put this together. Because that's what I'm going to talk about next. So, what's the tech, right? First component is line graph. Who's familiar with? I'm actually curious. Who's familiar with line chain? Maybe first one. So, okay, like 5 to 10 people. Line graph. Similar people, smaller subset, okay, 5. And Lang Smith? Only Okay, so Langsmith is the most unknown one. Okay, interesting. So starting with LangGraph, it's kind of the newer kid on the block within the ecosystem, and it allows you to define workflows. So think of it as, maybe people are more familiar with Airflow or Kafka or that kind of thing, like you have a DAG. You say, step 1, do this, step 2, do this, you can go left, you can go right, but you limit the actions it can take. And how you do it, you define a workflow, which is a state graph. You have some nodes and edges. Nodes define what you do, the edges define how you can go with it between the nodes. I'm not going to get into the graph theory. But these are basically the steps I defined in my program. So I summarized the block. You saw that. I described the image. You saw that too. I generate some captions. And then I have the human in the loop, which is, okay, thanks, is what happens there. And either we save the caption or we go into a feedback loop on the left side. Each step is using some kind of LLM. Summarize blog and generate captions, mostly because of the size of the context window, so the size of the input. I had to go with a commercial one or like a hosted one, so that's where I used Gemini 1.5 Pro from Google. There's probably ways around it by now, but yeah, you need a big laptop, all of that stuff. So I took the easy way out there. But cooler stuff, the smaller stuff was happening with Gemma, which is open source. Gemma 2, to be specific, 9 billion parameters. So that's what I use for the generation of the captions. Yeah, and then I save the captions, write them to disk. Easy peasy. I have 10 minutes left. I'm going to try to make this interesting enough. So code, I will maybe brush over a bit. You can probably either get it generated or you can find it in the documentation. But workflow, you can define like this. Yeah, you add nodes, you have a function to add nodes, you have functions to set an entry point, you kind of have functions to make things conditional. So for the human in the loop, that's where you add the conditional edge, basically. Node definitions is kind of think it as a lambda function or like a little unit of work that you want to do. Just a function with some annotations and yeah. In my case, mostly a prompt template, then an LLM that I feed the data, and then parsing some output. I think I visualized the refined captions here, which yeah, comes up with proposals and then feeds them back to the human. Another thing that LangGraph gives you is state and memory saver. The purpose of state and memory saver is kind of facilitate thread level persistence by storing and retrieving state of conversations across multiple interactions. So let's say I would expose this as a service to you guys and you generate a caption, you come back 1 month later and you pick it up from there, the system will still know what you were talking about back then. So that's what state kind of gives you. Yeah, and under the hood it's an in-memory key value store, and yeah, you can maintain context within a single conversation thread, so not like starting a new chat within ChatGPT. Definition, boring. Okay, I think 5 minutes about? Okay, 5 minutes, okay, I'll be quick. Still want to show Langsmith as well. So Gemini 1.5 Pro, main brains, biggest model, the summarization, multimodality, can see stuff, can see video, can summarize video. Has a massive 2 million context window, which I think is still the industry leading one. And for me, what was making it very easy, I work on Google quite a bit, so it's integrated with Vertex AI, so happy days. Gemma 2 is kind of, I call it the cool little brother of Gemini 1.5. It's the second generation in the Gemma family. There's a third generation announced this week. I didn't integrate it into this demo, but you can go and check it out. There is a nice technical write-up that you can Google, and it comes in 3 varieties. So I used the middle one, but there's a 2 billion one for smaller and quicker stuff, and a larger one for more complex stuff, 27 billion. Yeah, play around, go check it out. LangChain, mostly used in my case for abstraction and using different LLMs for different use cases, so the Gemma and the Gemini. And I use it mostly for constructing the pipelines. So you can see a chain here. We have the prompt. So I take a prompt template, give it some inputs, generate a full prompt. Then I give it to Gemma, say, do your magic. And then I parse it. I think the parsing is one I want to talk about a little bit, because not all LLM output gets consumed by humans, but some of it we might want to have consumed by machines as well, and that's where usually JSONs or XML or YAML is a bit more useful for the computer than for a human, and that's where parsing comes in play. Some LLMs do it internally, like the bigger ones, they have it as a feature. Some you have to kind of help it after the fact, and that's what I did with LangChain for Gemma. Yeah, not that interesting. Langsmith, because I have a video on Langsmith as well. Once you are done and happy with your demo, you want to probably put it in production if you're in a commercial setting, so that's where Langsmith comes in, into play. It gives you kind of debugging and observability. I was just in Richie's talk, and it's kind of made me think of this. If you want to observe how your system is behaving from outside, Langsmith is your library you want to use. Let's quickly watch the demo. I think that will be the only thing I have time for, and then we can maybe do some questions or something. And I'll have to talk again through it. So Langsmith, this is the interface. Yeah, so basically it's all the calls that happen in the background of my demo. And you can see some metrics like the tokens. Yeah, the different steps are kind of visualized instances of the steps rather than just a graph. So yeah, that's the whole flow. The whole flow of the breakdown of the whole chain. Okay, I'm gonna call it quits right here. Yeah, I had some wrap-up slides, but yeah, Gemma, Gemini, LangChain, LangGraph, Langsmith. We covered it all actually. So awesome.
We've still got a few minutes, so
yeah. Anybody has anything they really want to know? Then I'll just handle it that way.
Anyone has thousands of photos that they wish to caption that they've not been getting around to because it's too much work?
I got some swag for people with questions as well, so you're lucky.
Yeah, do you think if you would do this project now again, you would still build agents, or with the more modern models, you could just like skip and just like talk to the models without building like coding such a workflow? Like I'm asking because like models improved and like some people argue for like things that you used like these agents in the past might not be necessary anymore.
I don't think it was necessary in the first place. That's my honest answer. So it was partly for me to learn what was going on. So the means to the end was also learning what is out there. I think it was a good learning exercise. I think I could achieve part of it without all the, but I'm kind of interested in the tooling. It's
Makes
part
sense.
of it. I don't think, though, the problem is a function of model complexity at this point. So I don't think it would go better or worse than 6 months ago. But yeah, it's still kind of fun. You kind of talk to something rather than, you have some control over it. I like the LangGraph. The control that LangGraph gives you, basically, a lot.
Yeah. No, I agree. It's still a very cool project. I appreciate it.
Yeah, okay, we've got one here.
So what kind of agent did you use for your blog?
The LLM or the framework around it?
The framework parameters.
So the framework was just a LangChain. So LangChain was, I used to wrap the LLMs, kind of to control the flow of what the agent can do. I use LangGraph. So how I compare LangChain and LangGraph, because there's some overlap in functionality, I would say, right? LangGraph has LangChain has tool use, which kind of gives the power to the LLM, and that's what I didn't want. Yeah? Okay, perfect. That's what I didn't want. I wanted to have control over, okay, we definitely need to describe the image, we definitely need to summarize the blog post, we need to put the two together, and then I want some freedom for the LLM to generate maybe captions, because that's where the creativity comes in. That I don't think you can do with LangChain at the moment. And that's where LangGraph or I think Crew AI, other options are out there, but I decided LangGraph I think is a bit more low level, has some more control even compared to the other ones. I didn't experiment with those though.
Okay. Thank you.
Still got time or? One more.
Yeah, we can still fit in one more, although I'll invite the panelists to take the stage.
Swag, by the way.
I've lost my panelists. Yes.
Apache Beam Cup.
Okay, we have one. Harish. Peter. Peter, please take a chair. Is Harish in the room? Right, yes, okay. So we can squeeze in one more while we're waiting for the panelists to sit. Questions, comments? No one has thousands of photos they want to caption? Just me?
It's a unique problem. Makes me kind of happy and sad at the same time.
Thank you so much, Mattis.
Thank you. No, that's fine.
No, you keep that one. We will want to take questions from the audience, so we need you to be alert. Ready with mic. It's a panel, so we're going to take questions from the audience.
Actually thought that we
Hang on to that one.
a few minutes break in between.
Oh. Thank you. I was told that was not going to be possible, so we can move a little bit that way. Yes, a good conservation.
That's so weird though.
All right.
Let's see if anybody comes after,
You will, yeah.
after all these sessions. People maybe
Right? The audience just shrink.
access for lunch. Should we wait till 11:45?
Oh yeah, we'll wait. I'm just like, hang on. There are more people in this on stage than the audience. We're doing a panel starting a few minutes from now, so stand by.
And we're running into the lunch.
One-on-one and have a chat. We should have a soundtrack, play Blackpink or something, that'll bring people in.
Exactly.
Yeah, when they're in, stand or shut them.
I didn't realize. I'll sit down like this. Another A6 person. Are you a runner?
I am, yes.
You can always tell.
Yeah, it's the retailer. The biggest retailer in Singapore is Running Lab.
I don't run very fast anymore, but I do.
don't run very fast at all. But
I get
having
there.
a retailer who has a treadmill set up so that you can look at how you're running with a perspective you can't normally see.
I don't know how anybody runs in this.
It's what in fact I learned to run in Singapore. So for me, it's normal. If I go running in Australia or Canada, it feels wrong.
Sure.
Run at my custom pace. My heart rate is 20, 30 beats lower than it is in Singapore. Because getting rid of heat is the problem. If you're in a cooler air, then your heart doesn't beat as fast.
That one I agree, because I do both these different myself.
So it just feels odd. I think I'm running, but like not really exerting myself. It's just easy. Yeah. Let's put it that way.
Okay, final session before we break for lunch. There's been a little bit of adjustment to the schedule. Oh, okay. Some of which is reflected, some of which isn't.
All right.
I'll let Tony introduce the session. Thank you, Tony.
All right. Welcome, everybody. Y'all take your seats, and we'll be getting started. I'm Tony Wasserman. I am the chair of the session, and I have three distinguished panelists here with me today. But before we jump in, one thing I'd like to know about those of you, how many of you are working professionally in software, open source? And how many of you are students? All right. I was hoping it would be all one or all the other, but we'll try to accommodate everybody. The world of open source has changed a great deal in the time that we've all been working with it. As you can see from looking at us, we're all veterans of the software wars, and so when we go back and think about open source maybe 20 years ago, the people who did open source, they were unusual, and they wore T-shirts all the time. Right? They ate pizza. They lived in their parents' house. Maybe they didn't do laundry so often, but one of the things that's happened in the meantime, of course, is that people have discovered that there's a lot of good open source software out there, and that it works, and that the cost over time is lower, and there's big growth in commercial investment and venture capital, and so open source has become an important business decision. And as most of you know, open source code is in well over 90% of all the software that's released. Nobody builds a mobile application without using some kind of an open source toolkit, and people have stopped writing their own database management systems. There are many open source database management systems. People use Python, where almost everything is open. So the shift is really a very strong one, and yet one of the things that happens is that open source has become really a standard part of the software industry. And whereas 15 years ago, chief information officers and heads of engineering wouldn't consider putting open source code into their commercial products because they didn't know what it was and they thought it was strange. But now it's routine. But what that means is that they expect the quality of open source software to have risen to be as strong and as well supported as the commercial products that they've been using for many years. So that puts a lot of burden on those of us who've worked with open source. The expectations are higher. So with 20 years having gone by, what's going to happen in the next 10? And that's what we're going to try to answer in this session. With that as a starting point, let me ask the members of the panel to introduce themselves, and then I'll introduce myself a bit, and we'll go from there. So, Peter, to you.
Cool. So I'm Pete Membry. I'm the Chief Research Officer at ExpressVPN. I work on our R&D stuff, and I've been working in some shape or form of open source now for just over a quarter of a century.
My name is Harish Pillai. I have been in the open source world for like forever. I set up the Singapore Linux user group in 1993. That's 32 years ago. And I was with Red Hat for 20 years from 2003 to 2023. So right now I'm doing stuff in the space that I had done work in when I was in graduate school many years ago in the AI space. So from open source AI perspective is what I'm pursuing right now.
I'm Roland Turner. I run a small privacy and security consultancy in Singapore. I started running Debian before apt existed, which I think was 96. And publicly advocating for FOSS licensing in '98. So yeah, also a significant fraction of forever.
Good, thanks. And we're making rolling work after spending the morning making the sessions run.
Lolling around, doing nothing.
Yeah. So I'm Tony Wasserman. I think I'm officially retired, but that only means that nobody is paying me because I continue to work on open source. My first open source project, we released software under a BSD license in 1980. And then I started a company that was one of the first companies to put open source code in a commercial product. So I've been working on open source for a long time as part of all of my computer science career. So enough about us. What I want to do is ask a few questions of my panelists here and get their thoughts, and then we'll leave time for you to ask us about some of the things that are on your mind. So one of the things that's really been in the news over the past year or two is AI. Suddenly the way to have a successful company to raise venture money is to change your xyz.com to xyz.ai. And but when you say that you're doing open source and artificial intelligence, it's not clear what that means. I mean, can you use Copilot to generate code and put an OSI approved license on it? And can Copilot write open source code? That's an interesting question. So why don't we start with that one? And so let's start with who wants to go first?
Well, all right, let me go first, since I spent a lot of time on that. So I gave a talk yesterday about open source AI and the definition behind it. So the question you're asking is, what do we do with AI, and how do we engage from an open source perspective relative to AI? And if you are so I think there are a few things we need to keep in mind. In the US Copyright Act, it does clearly state that if you created using any tool, in this case an open source LLM, a large language model, to create source code as a 100% thing, that means you don't change anything, that code cannot be copyrighted because it came not from a human. But if that code that came out of the large language model has got some human component that you didn't, like you edit some stuff or whatever it may be, I don't know what percentage it would be, that can be copyrighted. So that's an interesting twist in the Copyright Act of the US. I'm not sure that clarity is available elsewhere. So from my point of view, the idea of if you want to do open source AI, as it stands today, the open source AI definition, which was released in late October last year, version 1, is sufficient but incomplete. It's sufficient because it addresses the 4 freedoms of software, the ability to use, to modify, to share, and distribute again. But it does not address the elephant in the room, which is about access to the data to train the model. Without that bit, you actually have a failure in the model, in calling it open source, from my perspective. So that's where I stand right now.
Yeah, I think I stand in pretty much the same place. Roland, do you want to add?
I was only going to offer that we've actually encountered a variant of this question late last century when IBM first opened its Java CC. This is a compiler-generating compiler. And they published the source code as a bunch of machine-generated Java. There was nothing disingenuous. This was within months of IBM successfully persuading Apache to make a foundation. It was just early days and the issues hadn't been thought through. But yeah, out comes the source code, which is the machine-generated intermediate form itself in Java source code to run as a compiler. And there was a bit of a pushback about that. And the FSFSA will say, hey, we already addressed this. What we say in the license is not source code. What we say is the preferred form for modifications.
Yes.
And I suspect that the question that you're getting at will turn a bit on that.
So it's a precursor to what we have now, because there was a big battle between Sun and IBM over this at the time. But good, Peter, do you want to add your thoughts? It's not required.
Yeah, I mean, well, there's not much to add after both of those. But yeah, I mean, I think it's going to be really interesting. The power that we're seeing from these tools, either commercial open source. Now, open source is obviously massively gaining ground here. I think from the corporate perspective, it's still trying to figure out, well, what can we use and how can we use it? Especially if you're working with companies that stretch multiple jurisdictions. And so the big question is going to be, well, I really want to use an open source model and I really want to go that route, but there are a lot of unanswered questions and a lot of potential legal issues. If the person who writes it is in the EU, but we're going to be publishing it to people in the US, does that make a difference? So a lot of stuff like with the internet, I think there's going to be a lot of challenges.
So the take-up of AI and certainly all the generative AI has been huge, certainly in Western Europe and in the United States and elsewhere. And for a long time we thought about there are open source companies and there are proprietary software companies, and that area has gotten a little bit gray. And AI, with this idea of the proprietary training data with open source code, makes it even grayer as far as I'm concerned.
I think it's, as you say, there's a learning process that will take years, and it's to get a sense of what the right way to think about it is will take us time.
Sorry, let me add a thinking perspective for all of you. We talk about the data as not being accessible as of now. I mean, it's not officially public. Some models have the code of the model generator itself in Apache or MIT license, whatever. And then they do publish the training data in whichever form it might be, and it's accessible to all of us. Now, that's all well and good. Now, I would like you to think about okay, let's start from here. Today is 1899. Okay? 1899. And there's this company called Open something or other, AI, I think they call it, just released a model that is based on the knowledge in 1899. Whatever, they have harvested whatever. And they have released a model. And here you and I are now going to query it as what we have been doing, and we're going to ask the question, can women vote? What do you think the answers are going to come back with?
Not yes.
So think about it. That's the importance of the training data provenance. Do I know what was it trained with? If I don't know, if I don't know what the training data is, we have a problem. So fast forward to this century, that's exactly where we are. And that's why the need for access and full provenance of the data for training is necessary before you can call the whole thing an open source solution.
So I love that example, and I think it's particularly relevant when we're talking about life-critical applications. So we've seen about autonomous driving, which sort of works, and we have a lot of medical instrumentation and healthcare where this is really a very, very critical point, because if you haven't read the latest medical journal to understand the latest test or the latest results, you're not going to get the right answer. So I think that's an important thing to keep in mind. And we'll get better, right? Because we've seen that kind of continuous improvement in technology forever, right? you know, we all talk about version 1.0, and in fact, the OS AI definition is version 1.0. So what we're going to see in 1.1 or 2.0, I think is going to be somewhat different. Well, we could go ahead.
I was just going to add one quick thing to that. Where we see people with these technologies, because they are in many ways like magic. I mean, the way that you look at the way that what they can do. But we've seen this with things like GPS, where people who are otherwise like sensible human beings have literally driven down dirt tracks or driven off bridges that don't exist, that they then later said they knew didn't exist because the computer told them to. So the ability to get that data up to date and be able to refresh it and to check it and to sanity check it. I think we're going to see a similar sort of kind of progression with this sort of technology as well.
So could we ask some of the people who are having conversations in the back to take it outside? Thank you. Thank you all. All right. It's a tough battle up here. All right. So now we have, now you're the corporate decision maker or the VP of engineering in a company, and you want to use AI in a product. Maybe you're a product manager. So now what's your problem is an interesting one where, and it goes beyond the open source, of course. It's, you don't always know what the program is going to do, right? And, you know, if you have a software engineering background, as many of us do, you know, you're supposed to be able to write the requirements, and you're supposed to test the program that you've written. And there's a set of testing data in addition to the training data. So to me, this is another area where we need to think about how we're going to do it. Because if you don't know what the program is actually doing, it's very, very hard to be confident about it. And if you're running a large corporation which has many billions of dollars of revenue, or the equivalent in other currencies, there's a big risk for you as a company to use this in a product that you deliver to customers. So we'll ask, how many of you feel okay about delivering a product to customers that has open source code, including AI technology?
Yes, until that last bit.
Yeah. So, you know, this happens all the time, right? You have the leading edge, the people who are brave and are going to do it early and take their chances, and you have the other people who are going to wait and see for a little while. We have an example. There's a company called Waymo, which is part of Google, and they have deployed self-driving cars in San Francisco. Okay, now, even if you don't know San Francisco, it's a city that has lots of hills, lots of narrow streets. It's not easy to drive in. Well, nor is Bangkok, for that matter. But, you know, are you willing to be a passenger in a Waymo car? Yes. Okay, so my family, that's what we use. Okay. Because my daughter especially, she doesn't want to talk to a human driver. She just wants to get where she's going. But it's an example of the application of the open source code that Google uses and the AI technology that goes into deciding and then, you know, deploying it. All right. Anything more? We could go on all day, of course, about AI and open source, but maybe we should, let me stop here and say, do people have some questions about this? Go ahead.
Mike, please.
Then we can move on.
Thank you. So my name is Nitish Tiwari. I'm from Gartner. I actually have multiple questions, but let me be very upfront about it. So first question is, do you think that open source initiative is actually late with open source AI definition? And since they were late, they published an incomplete definition. So I'm being very bold about it, maybe. But that's what my question is. Do you think that they are already late? Because companies have already modified, the open source AI definition in their own way, be it Meta, be it DeepSeek. They are hiding the ways, they are still publishing them under open source licenses. Do you think they are already late?
Yeah, I'm happy to take that one. I'm involved in the OSI license review procedure. I wasn't actively involved in the development of the definition, but certainly there was chatter throughout the process. I sort of hear two parts to your question. One is it late? And the second is it wrong? And so I think the answer to both those questions is no, but understanding where we are at version 1.0 and why it's the way it is not something that's been communicated very well. It's also a bit subtle, but the guts of it is trying to pin down the definition too early would have been a mistake. It's like regulators trying to, or worse, parliaments trying to write laws before technology is understood. We weren't really in a position to do that even 3 years ago. So I think the process started about the right time. It went fairly quickly too. The fact that you've got commercial interests wanting to open wash is completely unsurprising. It's exactly what's going to happen anyway. And it's not reasonable to say, if only we'd gotten a consensus definition out first and it was right a year or two sooner, then we could tell a bunch of sort of opportunistic companies to please stop being disingenuous. I don't think this is a problem. Over a period of time, as the consensus improves, those problems will be resolved. And I think we need to be looking at a 5-year, 10-year, 20-year timeline, not a 1-year timeline. On the definition itself, there are two fundamental problems that gave rise to the perhaps unexpected requirement about the data. One is the irreducible one, that there's a whole lot of really important AI work that's reliant upon data that's either infeasible to publish or straight out illegal to publish. And we talked about sort of medical applications. You categorically cannot publish the source data in any developed jurisdiction. But it would be absurd to say that the training mechanism and the demonstrations and the agents and all the other pieces that surround that, therefore, should never ever be within reach of open source. And so it made sense to say, okay, fine, we'll talk about the components that can be open source, and where we're dealing with data that can't be, then there's a requirement about what you disclose and how you disclose it.
Okay.
It's not quite nothing. So I know this is a long answer. So that was the first issue, and then the other issue is the expertise required. It's a much more complicated problem to evaluate obligations in privacy and in copyright, sorry, not copyright, privacy and other law that isn't copyright in dozens of jurisdictions. The OSI is really good at Berne Convention copyright, which is 180 countries uniform. For the other issues, it's more complicated. So the 1.0 is, here's the solution today. It's a workable starting point, but per Harish's proposal, step one is recognize that's lesser open source and have a version 2 that actually says you must have the data.
Okay.
Sorry, very long answer.
Good, thanks. No, that's very, very helpful, and it takes a while to explain this. So my answer is also no about whether it's too early, because what they've done is they've put something out there that's a basis for discussion and decision making. And those of us who work in this field know that you very rarely get it right the first time. It's not something that happens. And this is why we use decimal points to describe our versions.
Sometimes two.
Yeah, and what version of Chrome are we on? 137, I think? Something close to that. So for me, I know it's not perfect. I don't have the answers, and I think that we will, in fact, see forks of these definitions, the same way that we see forks of code. And at some point, the dust will settle, and we'll have more or less a consensus that will serve, I would say, the vast majority of people, if not all.
Maybe if I can add to your question, if you think about, again, time travel, let's go back to 1998, when the open source initiative was established. If you were to be in the audience and ask the question, are you too late in defining what open source is? And 20 some years later, that's the default, right? So all the proprietary guys have died. So the way I look at it today, because of the highly successful nature of the idea of open source, it's been co-opted by those AI companies from a marketing perspective. So we, and you're coming from Gartner, your organization should be far more critical about how they use the tool, the words in the stuff that they create. Because by giving them the leeway to do whatever they want, that is failing all of us. The collective us spent 20-something years trying to build this idea and value around the terms open source and the definition behind it. So I look forward to you from reporting this back to you.
No, thank you. Thank you for saying that. Yesterday I gave the session on my hype cycle that is already a published document, and we actually called it out that this is a problem in the open source space right now. This is a trend that we are also seeing where, so I actually presented it here as well, and it is already a published document, and we are coming up with another trend. So we are being critical about it, and we are calling it out that this is not open source. You are not providing the data sets. I can't replicate it, and we are calling it out publicly. So
can I add one more bit? Just because I'm very picky about this particular thing. Open source is never hyphenated. It's never hyphenated. Can you repeat this after me? Open source is never hyphenated.
All right.
There's a complicated linguistic explanation for this on the site.
Yeah, so I remember giving talks at Gartner conferences in 2008 and 2009, around then, where people were still trying to spell open source. So and for their business marketing. All right. Well, as I said, are we having fun? Okay. Good. So the next issue that comes into play is, how does open source, and particularly open source for AI, find its way into a company? So how many of you work in companies that have an open source project office? Oh, consulting opportunity. No, but how does your company decide when to use open source, which version to use, how to include it in products, all these kinds of issues, and how do your company decide, well, here's this piece of open source software, but it really consists of some code that your team wrote and 80,000 lines of components that were written by other people and imported into your code, and now you have this thing. Where did all the pieces come from? So now we have kind of two related problems, and I think this will fill the remainder of our time, which is, how do those decisions get made in your company? What are important concerns to you when you include open source in your product? And how do you govern the use of open source in the various projects across your company?
Yeah, go first. Of course, that's a big question. So for us at ExpressVPN, I mean, open source is one of the key technologies that we look to use. We prefer to use stuff off the shelf, and we prefer to give back to those communities rather than create whole new things of our own. So rather than it being proprietary, if there's some software that would otherwise be ideal for us, we will reach out to that project. Sometimes we actually fund the project to make the change. Others, we do the PRs and stuff like that. we do have a process to try and check licenses and try and figure out where everything kind of fits. But what we're seeing with a lot of languages is, you, like you said, you pull in one thing, you have 80,000 lines of code, but that thing will start pulling in things with 100,000 lines of code, and trying to keep track of all that is proving to be somewhat painful.
Absolutely, and you say off the shelf, but in fact, the thing that is on the shelf is composed, as you suggest, of a lot of different pieces with a lot of different licenses.
Oh, yeah.
And to go dig around there, and if you're doing manufacturing, there's this notion of a bill of materials. What are the things that go into the product that you built? And the same issue has now come up with
Yeah.
software.
So it's very easy. I mean, if you're in Rust, you have your cargo file, and you have, these are the things that I want to include. And that's all well and good, but it doesn't actually cover all the things that the people that you're including wanted to include, and the things that they include that want to include. And to be sure, if you're building something like autonomous driving or something with like a big safety critical thing, and for us, we feel that we are, in the sense that we protect privacy and security online, and people depend on it. You really have to do that digging and start going back through the lists. But that's a mammoth task, and it can change.
Right. So now you have this open source component that you're using off the shelf, and it turns out that one of the components that it uses has a bug that has to get fixed, and somewhere down the line, somebody fixes it. Now the question is, do you use the fixed one when you've already deployed the old one?
Yeah. So in our case, we actually do very proactive releases for exactly that reason. But often on this list going up, as it feeds into your stuff, often it'll get fixed very far upstream. It'll flow down, and then there'll be one dependency somewhere that isn't necessarily interested in fixing this, or the project's gone on a holiday, or the project maybe ceases to exist, and then it gets stuck there. So then you have to think, well, how do I fix this myself? Do I patch it myself? Do I work around it? Do I replace it? It is a constant battle to try and even figure out how you would go about doing it.
So, do you want to add to this?
How long have we got? I think a large part of the answer is unavoidably going to be better tooling. The ability to discover what your ROM actually is, where that can now be readily thousands of packages. It's far beyond what can reasonably be done manually.
So there are these software composition analysis tools that are out there, ScanOSS and things like this, and Black Duck going way, way back. So they'll tell you what's in there, but they won't tell you when it changes.
So yes. Singapore Scantastic, something. Scantist, there we go, are working on exactly that problem, because what they're trying to do is give you a better basis for evaluating the risk. So if you've got X thousand packages in the transitive closure and 200 open CVEs, it's like, what do we need to know? How do we act? It's not perfect because no one has full coverage regression tests, so you can't necessarily work out whether a particular bug is implicated in your environment, but it's ongoing work to improve the tooling to help narrow the focus so that you can correctly prioritize stuff that often has to be done at emergency priority. If you've got stuff that's in production for finance or healthcare and you've got reason to believe there's a remotely exploitable bug, you can't ignore that. You have to move in hours. And so,
Can I ask a question, a thought question for all of you? Based on what Tony said, and with Roland and Peter suggesting things, do you think something like this, the knowledge that we are kind of sharing out here, would be best placed if it is distilled into something that can be repeated to the C-suite of organizations? To organizations, the CEO, the CIO, the CTOs, who don't necessarily have the background of years of living and breathing this technology that we talk about. Do you think something like that, that is turned into some kind of a mandatory, I don't know whether it's mandatory, but you better take this course, for example, so that you better understand this? So I'm just asking, do you think something like that would be useful?
Totally hypothetically.
Totally hypothetical. Yes, it's useful. The reason...
Microphone?
That's not your comment. Okay, you have a question. All right. The microphone, please.
The concept is useful. Nobody commercially will use it. This is the reason why big companies avoid open source, and they want to hire a commercial place so that they can point to somebody and fire when it goes wrong.
But that's not what's happening anymore. That's changed quite a bit.
Well, I think that's what these open source services companies are providing. They're providing that I'll take responsibility for you layer. It's been this case in the security world since the 90s.
Yes.
And open source is just catching up to that and getting credibility within that. In 2006, I brought the first open source software into Reuters. It took me a year and a half to get them to accept Postgres for free rather than pay $250,000 per license for their SQL server thing.
Right.
Took me a year and a half.
Yep. No, absolutely. But that's, as I say, it's not as bad now as it was in 2006. Because I published a paper in 2006 called "Building a Business on Open Source Software," and that's very relevant. But time marches on slowly.
We had another response.
Yeah.
So I completely agree with this guy over here, but from a slightly different angle. I'm one of a software foundation type of thing. I've been spending a lot of time in Europe at the moment dealing with the European CRA related to.
Oh God!
Well, it's not a problem, right? It's going to actually fix the bowwag that it will create about knowing who the supply chain is. Whole software bill of materials, your CNA analysis, your VEX stuff. It's all going to turn up in tooling because of that. So this is generally a very good thing. The interesting problem that's going to occur, and I think I would agree with this guy here, is that it will possibly create a band gap in the market. There will be, and I'm on the bubble cusp of this. I'm a language thing. I'm unfortunately not Go or Java, which are too big to fail, right? I'm on the language cuff. If I don't get my stuff sorted out, I will be either disintermediated by these guys, or somebody's going to go and disintermediate the thing. So think Ernst & Young, Price Waterhouse Cooper, and whatever it is. There are political dangers here for the open source community related to insurance and a whole bunch of other types of things that are not well talked about at the moment. So we're having a two-dimensional discussion about security when in fact there's a three-dimensional space problem associated with policy, insurance, business stuff. And it's not clear that we could even give a sensible presentation to C-suite guys at the moment because it's not obvious what we want to do from the other side.
Right. So that's why I asked the question earlier about which companies have an open source project office, because what we've seen, going back to the very first one that was at Hewlett Packard of all places, in about 2004, this is the way that companies, they used to first have lawyers who started the OSPOs, but it's now expanded quite a bit. There's an organization called the To-Do Group, and it's really founded by the top technical open source people in a bunch of the Silicon Valley companies. And they've done some very good reports. If you go to todogroup.org, you can see a lot of what they've written about how to create your own open source project office. And what this means is the issues that you've raised, kind of filter through there. And engineers in these companies get open source training. They get training on open source governance so that they don't just steal this piece of code from here with some weird license and put it in their product, because that's a problem. I think we're still very early on the adoption curve of open source project offices, and as they move along, they'll be the natural home for addressing some of these issues and doing the education, or at least offloading it from the people who are out there raising money and having lunches.
Can I maybe add something? Maybe I'll pitch this. Well, I do have a course that I'm teaching in Singapore. It's called the Chief Open Source Officer Program. It's an executive level program targeted at the C-suite for them to understand everything that we have been talking about and then some, including related to AI from an open source perspective, OSPOs and so on. The intention of this program is so that we can create and drive that awareness building across the management of every industry, including government, so that they understand what this means and they don't have to be absorbing it from conferences and events and speaking to the engineers and or some news item that comes up. So there is some form of rigor in some sense of education so that you understand what this is and ask the question. So this is happening next month in Singapore. So if you want to look it up, please look for Chief Open Source Officer Program.
Great. Yes, sir.
Mike.
I just want to add a couple of points here. I mean, I think the bigger problem is that there are still IT organizations who think that they don't have open source. And, just to let you know, in my published research note, I have called it out that it is impossible to build software without using open source. So, again, we are calling it out that it is not free to use as well. So there are misinterpretations around open source that it is free to use. It is, it is something that anybody can go ahead and use it. Everybody uses it. So we don't need to pay attention unless something like Equifax happens or Heartbleed happens or Log4j or XZ backdoor attack happens. So I think the lack of education is a much bigger problem in every aspect of it. And yes, open source program office is one way to resolve it.
Yeah, so, I think, again, we can look back a little bit. In 2005, I was invited to a company that builds defense systems in the United States. And I usually don't go to those places, but I will. And I started talking to some vice president, and he said to me, "We don't use open source." And I said back to him, "Do you want to bet?" And, I actually managed to get him to do a source code analysis, and let's say he was surprised. And then he said, "Well, we don't want to use open source." And I said, "Okay, so first you have the issue that you raised of spending huge amounts of money with a proprietary vendor, but you also have," and this is what got him. I said, "Well, you could go out and spend your engineering time building a new database management system which has no open source code. It's all built by your engineers in your company, and you're going to test it and support it and do all these kinds of things for years. Meanwhile, the adversaries of the United States are going to use MySQL, and they're going to be working on the value add of the application while you're still working on the foundations. And guess who's going to finish first?" And that stopped him. He said, "Well, maybe we need to look at this."
It's an effective sales pitch.
I wasn't selling anything. All right, so we have time for just a couple more minutes. So why don't we do this? Why don't we ask each of our panelists to give us a closing thought? And I'm not very hungry, so I'm not going to rush off to lunch if people want to come and ask questions one-on-one. Go ahead, Roland, you start.
I don't know that I had anything prepared for this. I think we are, for better or worse, living in a particularly exciting time. The transition.
Interesting times, Confucius said.
Yeah, we have, for better or worse, we live in interesting times. I have some very real concerns, and I talked about them at length yesterday, but I think the future is bright. I think there's a whole lot of interesting possibilities that are becoming more and more. I won't bore you with an hour of what they are, but I'm very bullish.
I would say I'm bullish as well. I think the fact that we are here today speaking about this, what I want to see really is by next year we don't have to talk about this. It is the norm. It is understood. People get it. Let's move on. Let's build the next best thing. We don't have to keep referring back to free software, licensing, Move on. There are many more things that we need to do. There's so many more things we need to build instead of going around in circles. This is really navel gazing we are doing after 20-something years. We're still looking to see how do you do this better. Let's fix this now and let's move on so that we don't have to talk about this and say, oh, that's an archaic way of talking. Right? So let's hope we are done with that. That's my hope.
Peter?
I mean, for me, I'm also bullish on what we're going to be able to pull out from this. I think it's more interesting right now because these technologies are growing and improving at such a vast rate, whereas historically some of the systems have been able to keep up with that. Now we are seeing a bit of a gap. But again, the fact that we're here talking about this gap and how to close the gap, I think will allow us to kind of catch up eventually, or let's say in time. But it's also going to set the foundation for the next thing that's going to come. And so next time we get some sort of like a super AI or something like that, or some new technology, I don't think we'll get blindsided by how fast the whole thing can move. I mean, we probably will actually, but
I don't believe
at
that.
least we'll have. I mean, at least we'll have some plan or something that we've done previously. So.
All right. So I have one piece of good news. There's enough work out here to keep everybody employed. If you become knowledgeable about some of these topics we've talked about today, you will be in demand. And I see that happening almost everywhere, so that's good news. All right, so I've had fun doing this. I hope you did too. And I learned a few things while doing it. So thanks for coming to the session, and we'll wish you a happy day. Thank you.
Thank you, John, Peter, Harish. That's all for this morning's session in this room. We're back here in right on 1 hour, 1:30, to hear about indoor mapping with OSM. See you then. Thanks.
Well, thanks.
No problem. Thanks for having me.
Good to meet you, sure. Thanks. That was good.
Hypothetically, I was like, it's not hypothetical, he's running his own course. I think if you're at the very least establish
this is Richard from China.
But it's
Okay.
involved in that program. Have a word with Rich about where and how it's pitched, because it may also be relevant to clients. It's not just Thailand, it's the entire region.
我觉得最简单的办法是就直接用新加坡网到酒店，但有时候酒店 WiFi 就不行。
Yes, and that's the problem. That's the problem. Right? So that's the problem.
香港的易速就不用翻墙，但是那个是什么
I'm trying to, Erlang, dude, the ultimate language.
Is there a point where people put open source, they make a library that's open source kind of on purpose to try and say that, okay, well, someone's used this now, then all the, a lot of big software thinks that should be open source. It's more of a, I was seeing this thing between like MIT, and some people say like, well, just MIT license. Just a small basic discussion, but then they'll say like, well, if someone takes an MIT license, they can improve it, make it obfuscate what it's doing, and then sell it.